So can you help me now? For the G1 graph, G2 is complementary. G1 contains 7 edges. G2 contain how many? I'm repeating the question once again. Listen properly. This is the place where we stopped yesterday. Can you listen? Can you listen? Hidden. Can you listen? Can you listen? This is the place where we stopped yesterday. I'm repeating once again. G1 is a graph to this complementary graph is G2. G1 graph contains 7 edges. G2 contain how many? Please let me know. G1 graph complement is G2. G1 graph contains 7 edges. G2 contain how many? Can anyone say to me? Can any guess? Any guess? Any guess? Yeah. So in the G1 graph, I didn't said vertices. So you need vertices. Am I right? You need vertices. Am I right? G1 graph complement is G2. G1 graph contains 7 edges. G2 contain how many edges? Without saying vertices in the G1, how can I say? So you assumed n vertices are there. N into n minus 1 by 2 is the complete graph. Minus 7, you will get the G2. So some people are thinking that, G1 complement is G2, both contain same edges. No, bhaiya. Complemented graph, you cannot say both contain same edges. That is called self-complementary. Are you getting? Complementary graph is different. Self-complementary graph is different. When you say self-complementary graph, not only complement, it is isomorphic also. Are you getting? Complementary graph different, self-complementary graph is different. Yeah, I know. That is the reason I asked you. Complementary graph is different, self-complementary graph is different. When you say self-complementary graph, first of all, you have to find out complement. After complementation is over, G1, G2, G1 complement G2, G2 complement G1. Interesting thing is they are isomorphic to each other also. For the G1, complementation I got G2, I got to know that they both are isomorphic to each other. Then I can say that G1 is a self-complementary graph. When you say isomorphic, vertices also same, edges also same. I think everyone knows this. I know you may be having small doubt, right? I want to clarify, I said to you. Now come here. Now. Everyone listen, now come here. Make sure everyone will get. V1 graph, okay, let me change the color. This is some other topic. V1 graph, V2 graph, it is some other graph. V1 graph, V2 graph, sorry, V1 vertex, V2 vertex, V3 vertex, V4 vertex. Yeah, careful. This is some other topic. Yesterday's topic and today's topic, no relation. Yesterday's topic, today's topic, no relation. Please, everyone listen. This graph contains how many vertices? Over almost graph theory going to be over. 1 or 2 classes are left out. Graph theory also over means half of the discrete mathematics you done. Let's complete graph theory also. Right? Almost 2 or 3 classes. I am thinking in this week it will be over. If you merge all of them, you will get approximately 4 videos. Maybe you will get 4 videos. If you merge all of them, you will get approximately 4 videos. 4 for the mathematical logic, 4 for the right graph theory. Right? Fine. Now concentrate. How many vertices? It is a different story. It is a different story. How many vertices? 4. Let me write. 4 vertices. How many edges? How many edges? Concentrate only this. Concentrate only this. Don't link yesterday's story. I think 6 edges. Yeah, next one. Can you help me? Now? V1 to V2. Everyone listen. V1 to V2. V2 to V3. V3 to V4. Can you say this one? V1 to V2. V2 to V3. V3 to V4. Can you say? Is it sequence of edges? Is it sequence of edges? When you say sequence of edges, you cannot lift the pen. Listen, you cannot lift the hand. When you say sequence of edges, you cannot lift the hand. One edge, see, one edge there, one edge here, then it is not a sequence of edges. When you say sequence of edges, right? So you cannot lift hand. So see this one, continuously how to write. See, continuously you are going, that is called as, right? See this one, continuously you are going, it is a sequence of edges. Remember, sequence of edges is known as path. Right? Let me write now. Path is nothing but sequence of edges. Path is nothing but sequence of edges. Yeah. Now let me write one by one. Is it path? V1 to V2, V2 to V3, V3 to V4. Is it path? Path is nothing but sequence of edges. When you say sequence, you cannot lift hand. Path is nothing but sequence of edges. V1, V2, V3, V4. Okay, I feel you are a little bit okay. This is the one path. Path P1. Let's take one more path. Can you help me now? Let's take one more path. See, everyone listen. Everyone, V3 to V4, V3 to V4, V4 to V2, V2 to V1, V1 to V3. Can you see it also path? V3 to V4, V4 to V2, V2 to V1, V1 to V3. Is it also a path? Is it also sequence of edges? Is it also sequence of edges? Yes. This is also a path. To this path, starting vertex is equal to ending vertex. It is also a path. It is a closed path. Right? Above one is open path. Means it is not a starting point, ending point different. It is a path only, but open path. Starting vertex, ending vertex not same. But if you see the P2, it is also sequence of edges only, but starting vertex is equal to ending vertex. It's a closed path. Right? Fine. Open path, closed path, everything is fine. Bhaiya, are you okay? Bhaiya, are you okay? Path is sequence of edges. Closed path means starting vertex, ending vertex same. Open path means starting vertex, ending vertex need not be same. When you say open, right, they are not same. Right? Until now, I think everyone is okay. These are small things. Everyone fine. Now listen, everyone fine. Everyone observe. Given graph contain how many edges? Given graph contain how many edges? 6 edges. Given graph contain how many edges? I am saying it contains 6 edges. Given graph contains 6 edges. Now what you do is, everyone observe. What you do is, can you find a path in the given graph where every edge, listen, can you find a path? Can you find a path in the given graph in such a way that every edge will be visible, every edge will be visited exactly once? In the given graph, can you find a path where every edge will be covered exactly once? Every edge will be covered exactly once. In the given graph, can you find a path where every edge will be covered exactly once? But remember, it should be a path. Path is a sequence of edges. Can you check once? Exactly once. So I am writing in the given graph. See the answer. In the given graph, if you find in the given graph, if you find a path in the given graph, if you find at least one path, in the given graph, if you find at least one path in which every edge present exactly once, then we can say that given graph contain Euler path, right? Please write down this. In the given graph, if you find at least one path in which every edge present exactly once, then we can say that given graph contain Euler path. Right. Now can you help me? So I'm just checking. Can you help now? Every edge is exactly once or more than once? Every edge is exactly once or more than once? Every edge is exactly once. Someone is saying something. Let me read this. So in path definition, is edge can be in the path, right? In the path definition, edge can be repeated. Yes, anything. Right? In the path, someone is saying that path is a sequence of edges. Any sequence you take, right? The Shiva is asking, and the path definition is the edge repeated. See, sequence of edges, nothing there. Sequence of edges is known as path. Right? Next one. In the given graph, if you find at least one path in which every edge present exactly once, then we can say that given graph contain Euler path. Now let's see once. Everyone observe. Yeah, this one I am starting. See this? Every edge will be exactly once. I'm starting. Every edge will be exactly once. So repetition is not allowed. See the answer. So I visited this edge. Okay. See the answer. I visited this edge. And after visiting this edge, careful. I visited this edge. After visiting this edge, right? You cannot lift the pen. That is the meaning of sequence of edges. You cannot lift the pen. So you can go anywhere, no problem, but you cannot lift. So it will go to, if you want, you can go like this. I went here. Sorry for this. I went here. So otherwise I can use another color because some problem is coming. I'm using another color. Yeah, see this. I went like this. Right? You can go anywhere, no problem, but pen you cannot lift. You can go like this. Right? You can go anywhere, no problem. You can go like this. You can go anywhere, no problem. So you can go like this. Right? Next one, you have two possibilities. You can go either above or below. I can go below. Now see this one, I can go below. But can you help? One, I am at V4. But one edge left out or not? I am at V4. One edge left out or not? If you want, I can do once again. See, I went like this. I went like this. Remember, Without lifting hand, you have to go. I went like this. Now, what is the unfortunate thing? I want to cover one more edge left out. I want to cover it, but you have to repeat the edge. But what he is saying, at least one path in which every edge present exactly once. In the given graph, if you find at least one path in which every edge present exactly once, then we can say that given graph is Euler path. Given graph contains Euler path. So if anyone find out Euler path, please let me know. So that is the Euler path definition. Now see this one. Careful, one more. It is a one note. One note. See the one more note. See the one more note. In the given graph, if you find at least one Euler path, in the given graph, if you find at least one Euler path, and to that Euler path, guarantee you will get. To that Euler path, starting vertex is equal to starting vertex and ending vertex same. Then we can say that given graph contain Euler circuit. In the given graph, if you find at least one Euler path, and to that Euler path, starting vertex and ending vertex same, then we can say that given graph contain Euler circuit. Next one, one more, maybe, if you want, I will write. Continuation also, okay, no problem. It is a note 1, it is a note 2, note 3. Continuation, if you want, you can continue also, no problem. Note 3. Within few minutes, clear definitions I am writing. If the given graph contain, careful, if the given graph contain at least one Euler circuit, if the given graph contain at least one Euler circuit, then given graph is Euler graph. This is the way of checking given graph is Euler graph or not. If the given graph contain at least one Euler circuit, then given graph is right Euler graph. Are you okay till now? Please let me know if anyone having doubt. Sir, I have this doubt. Please let me know. I will take care. Check all the definitions. Just I written definitions. I didn't said anything new. Just I written the definitions. Only definitions I written. Please let me know if anyone having doubt. Small doubts are there, definitely. Small doubts are there, definitely. They will be solved right within few minutes. I will give one problem, guarantee you are okay. Check. Sir, I have this doubt. You ask me, I will help you. V1, V3, V1. Check. Someone is saying that V1, V3, again V1. Again V1. One edge only you are going, right? So she was saying that V1, V3, V1. Is it closed path sequence of edges? Because of direction not there, you may go back again. Fine, that is also okay. But there is no meaning in that, but anyhow, that is also okay. Sequence of edges. Simply definition is sequence of edges. Right? Simple definition is sequence of edges. It is not making any sense, but whatever you asked, that is also fine. So let's see this one. V1, because of it is a directed graph, it looked like that. Is undirected, right? Because of it, the undirected graph, it looks like that. In the directed graph, there is no meaning for that. Now let's see the sign saying V1 to V2, V1 to V2, V2 to V3, V3 to V1. Okay. V2 also. So I will read once again. V1 to V2. Let me use another color. V1 to V2, V2 to V3. Yeah, I am reading. V1 to V2, V2 to V3, V2 to V3. Next one, V3 to V1. Okay. V1 to V2 again. That is also okay, right? There is no problem. See, simply path is nothing but sequence of edges. If you want to repeat, you can repeat. If you want to repeat, you can repeat. It is a simply sequence of edges. Right. Now anyhow, you no need to think that much about that. Simply whatever definition is there, please go through it. Path is nothing but sequence of edges. You write any, the only condition here is, listen, the only condition here is you cannot lift the pen. You have to write continuously. You cannot lift the pen. Remember this. This is the only condition. Path is a sequence of edges. You cannot lift the pen. Right? Now come to the next one. What is the, right? So what is the Euler, right? Remember this is the interesting one. See this one. Remember this is the interesting one. Exactly once. You cannot, right? You cannot neglect anyone. You cannot neglect anyone. You cannot take one person repeatedly also. Here repetition also not allowed. Right? In the given graph, if you find at least one path in which every edge present exactly once, then we can say that a given graph contains Euler path. So this is only required. See, above one. If I don't say above one also, no problem. If I say path definition also, I can go directly. Path means simply collection of edges. Combination of or sequence of edges. Right? See the Euler path. Every edge should be visible exactly once. And one more, to that path, starting vertex, ending vertex, same Euler circuit. And one more thing, if Euler circuit is there, given graph is a Euler graph. Euler circuit is there, given graph is a Euler graph. Right? Fine. These two things, 2, 3 is right. Sorry, 1, 2, 3 is important. 1, 2, 3 is important. Remember. 1, 2, 3 is important. No need to bother anything about the path. In some classes, without path definition also, I will directly start. 1, 2, 3. 1, 2, 3. Please careful. What is the Euler path definition? What is the Euler circuit definition? Right? Euler circuit is there. Given graph is Euler graph. Now let me ask you one small line. When can I say a graph is Euler graph? Give answer to me. When can I say a graph is Euler graph? Please give answer to me. When can I say a graph is Euler graph? I'm expecting answer from you. When can I say a graph is Euler graph? When it is having Euler graph. Arey Jaya, Euler graph I am talking. Jaya, I am talking Euler graph. What's the answer? Euler graph. What? Right. Gayatri saying at least one Euler circuit possible. At least one Euler circuit possible. At least one. Gayatri, correct. Right? At least one Euler circuit. Right? Euler graph means Euler circuit should be there. First of all, Euler circuit is Euler circuit should contain Euler path or not? First of all, Euler circuit is contain Euler path or not? What is the Euler circuit? For the given Euler path, starting vertex is equal to ending vertex. Right? For the Euler, right? Euler circuit means first of all it should be Euler path. If you want to prove one graph is a Euler graph, at least one Euler circuit required. What is Euler circuit? First of all, it is a Euler path. Starting vertex is equal to ending vertex. First of all, what is Euler path? Every edge should be exactly visible once. In a path, every edge will be visible exactly once. I'm thinking you are little bit okay to get the confirmation from your side. You may be having some doubt, I can understand. Today's class, in my opinion, will start now. Today's class, in my opinion, will start now. Right? See this. Today's class, in my opinion, it will start now. Take example. It will give full clarity. These problems will give full clarity. Example. A, B, C, D, E, F. Yeah, this is the problem. Now you identify yourself. Listen, the question here is it Euler graph? Is it Euler graph? That is the question. How you are going to solve? Please solve. Don't think much. Don't think much. Whatever you understood, can you try once? Is this graph is Euler graph? That is the question what I am asking. So what is the answer you got? Careful, this is the first problem. This is the first problem. You will easily get, just concentrate. What is Euler path? Don't by heart unnecessary things. What is Euler path? What is Euler circuit? What is Euler graph? Those only required. You don't concentrate on unnecessary things. What is Euler path? What is Euler graph? What is Euler circuit? Yeah, is it Euler graph? The question here is it Euler graph? Everyone try. If you try now, it will become easy. If you try now, it will become easy. Euler spelling is E-U-L-E-R, Euler. Yeah, can I give answer? Yeah, you tried whatever possible you tried. Whatever possible you tried, I am giving answer. Careful. Careful everyone, I am giving the answer. Euler path, listen, if you want to check it as a Euler graph or not, you have to check. You have to check Euler path is possible or not. If at all Euler path also possible, then you have to check Euler circuit is possible or not. If both are there, then it is a Euler graph. Let me try one by one. Remember, every edge should be covered exactly once. Remember, every edge should be covered exactly once. I am covering now. I am covering. Can you see this one? I am covering. Every edge will be covered. Every edge will be exactly once. See this? See this? See this one? I am going like this without raising the pen, without without making hand out. Let's see how I am doing. I will go like this. This one. I will go like this. 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 But what about this edge? Fine. I am at here. So I came like this. I came like this. I came like this. I came like this. But what about this edge? Some you may say that, sir, I will go back. If you go back, edge is repeating. If you go back, edge repeating. Am I right or not? If you go back, edge is repeating. Am I right or not? Bhaiya, if you go back, edge is repeating. Am I right or wrong? So first question I want to ask you. Given graph contain Euler path or not? Given a graph contain Euler path or not? That is the first question. Yes or no? Given a graph contain Euler path or not? Yes or no? Yeah, I think see Atul saying that Euler path exists and he is giving some path also. That is the reason I said to you. Listen, that is the reason I said to you. In the given graph, if you find out at least one Euler path, see every path need not be Euler path. If you can find out at least one Euler path, so can you help in my answer from which vertex I started? In my answer from which vertex I started? I started. Now see the beauty. I started from A. It is not working. I started from A. It is not working. Some people are asking, right? But Atul is saying that it is available. Atul saying it is available. I started from A. It is not working. Let me start from B. See the answer. Everyone listen. Let me start B. Is it possible or not? Let's check. Let me start from B. Everyone observe. Let me start from B. I will go like this. 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 See, everyone covered. I just went like this. I just went like this. Can you guess every edge covered? Every edge covered. Every path need not be Euler path. If you can find out at least one path where every edge covered exactly once. I started from B, I came back to E, right? So every edge covered. If you want, you can check. Any edge left out. Bhaiya, please let me know any edge left out. I'm not saying that every path is Euler path. I am not saying in the given graph, if you find out at least one path in which every edge is visible exactly once. Final question. Is it Euler path possible? Final question I want to ask you. Is Euler path is possible? Atul said to me, Euler path exists, sir. That is the reason I tried. Yeah, I think Shakir is saying one interesting line. Sir, Reddy sir, every edge will be covered exactly once. So that is called Euler path. I am very happy. But vertex repeating, na? Bhaiya. Right? So Shakir is saying that, Reddy sir, every edge will be covered exactly once. I am happy. But vertex repeating, na? If you concentrate, vertex repeating or not, that is called Hamiltonian. What is the name? That is called the Hamiltonian graph. In the Hamiltonian graph, you bother about vertex repetition. Are you getting? In the Hamiltonian graph, you bother about vertex repetition. In the Euler, you bother about edge repetition. Can you help Euler starting with E. Euler is starting with E. Euler starting with E. So concentrate on edges. Concentrate on edges. Euler, just I remembered like that. Oh, Euler means edge. I know one thing. Hamiltonian is something related to vertex or edge. Euler also something related to vertex or edge. One person will concentrate one thing. Oh, Euler starting with E. I remember like this. That is the reason I remembered these many days. You also remember like this. In the case of Euler, you don't bother about vertices are repeating or not. And one more thing. Listen, one more thing. Careful everyone. Path is a sequence of edges. Path is a sequence of edges. Whether you repeat or not, whether you cover everyone or not, none of the business. Right? Whether you listen, you are some people are saying, sir, in the path, should I cover every edge? It is up to you. Sir, in the path, can I repeat? It is up to you. Then what is the path, sir? Sequence of edges. Now let's come to conditions. Listen, let's come to conditions. Every edge exactly once. That is called a Euler path. Every edge exactly once. So starting vertex is equal to ending vertex. Right? Euler circuit. Let's see this one. Euler path is possible for this. Can anyone guess to this Euler path? Starting vertex is B, but ending vertex is E. Both are not same. Euler circuit not possible. If anyone say Euler circuit is possible, please let me know. Remember, if these two are possible, then it is a Euler graph. One fail also fail. It is a very interesting question to ask you. Given graph is Euler graph or not? It is a very interesting question to ask you. Given graph is a Euler graph or not? It is a very interesting question to ask you. Given graph is a Euler graph or not? Remember, both should be there. Both should be. Euler path should be there. Euler circuit also there. Hello? Euler path there, Euler circuit there, then Euler graph. One fail also fail only. Sir, here anything to do with the degree of your vertex? Don't know, Bhaiya. Raj Bhaiya, don't say future, Bhaiya. Bhaiya, concentrate on the ongoing class, Bhaiya. Bhaiya, concentrate ongoing class, Bhaiya. Future don't predict, Bhaiya. Can we move further? Remember everyone, Euler path and Euler circuit, both there, then Euler graph. Some people are saying, sir, Euler path there, na? Then say Euler graph. No, Euler circuit should also be there. Then the given graph is a Euler graph. And one more beauty. Listen, one more beauty. This is not a Euler graph, okay. At least is it semi-Euler? Semi, right? Semi means at least Euler path possible. Yeah, if you want, you can say semi-Euler graph. Semi-Euler graph. If you want, you can say. But it is not Euler graph. If you want, you can say semi-Euler graph. But not Euler graph. Somewhere I seen semi, right? That is the reason I written that also. Okay, can we go further? You are almost okay. Can we go further? Someone is saying that if Euler path is not there, then Euler circuit is not possible. Of course, first of all, Euler circuit is a Euler path. Am I right? Can you help? Euler path is not there. Is there any meaning of checking Euler circuit? How Euler circuit is possible without Euler path? Yeah. How Euler circuit is possible without Euler path? How it is possible? So Shiva is saying one interesting thing. Sir, Euler graph means only concentrate on Euler circuit. Are Shiva, how will you get Euler circuit without Euler path? How will you get Euler circuit without Euler path? He's saying on camera, I want to see your beautiful picture. I want to see. Right? Because I said na, right? Shiva, love you, right? Without you, class is unbearable. That is the reason he is misusing. He is misusing the class. Reddies are on the camera, right? Otherwise, I'm thinking that I'm missing something, right? So Shiva want to say that Reddies are not only you, right? I am also missing you. You want to say this, right? Right. Anyhow, fine. Thank you. Thank you so much. You only say how Euler circuit is possible without Euler path. Shiva, you only say. Shiva, is it possible? So indirectly we are concentrating or not? Indirectly we are concentrating Euler path. Euler circuit means it should be a Euler path where starting and ending same. So indirectly we are concentrating. And one more thing is only Euler path, Euler circuit is not the semi-Euler graph. It is not Euler graph, but semi-Euler graph. Okay, fine. Right. Now I think you are little okay. In the next problem, you will be more okay. Right. Take the next problem. Take the next problem. One more example. A, B, A, B, C, and D. A, B, C, D. E, and F. It is a graph. Check yourself. Euler path is possible or not? Euler circuit is possible or not? Then what about Euler graph? Verify properly. Don't say whatever way you like. Don't say whatever way you like. Can I give answer? Many people may be tried. See the answer. See my answer. See my answer. See my answer. Euler path. See the answer. Euler path, Euler circuit. See this? Can I go like this? Can I go like this? Can I go like this? Is it okay? I started from B. I came back to B. Everyone covered. It's a very easy path. Just one walk. Just one walk. So Euler path is possible. Euler circuit also possible. Given graph is Euler graph. Can I go to next problem? Can I go to next problem? Are you okay? Are you okay? If you can find, you may say that, sir, one more path is there. Maybe so many. If you can find out at least one Euler path, to that path starting vertex is equal to ending vertex, means Euler circuits. So given graph is a Euler graph. Remember, Euler will concentrate only on edges. Only on edges. Exactly once every edge should be covered. Exactly once every edge should be covered. Okay, perfect. Let's go to one more example. You may get more. See, now itself you got clarity. Further problems, you will get more clarity. Further problems, you will get more clarity. Can you take the one more problem? You are fine now. You are, I think, in my opinion, you are a little bit okay now. A, take this. B, C, D, E. Yeah, check yourself. Euler path is possible or not? Euler circuit is possible or not? So given graph is Euler graph or not? This is the way of asking. This is the way of asking questions. Why you bother about path is what? Distinct there in the exam they will give. If really path definition required, because different books are having different. One book say distinct, one book say not distinct, one book says sequence of edges. You no need to bother. Path is a combination of edges or sequence of edges. Don't bother. They are repeating or not. Concentrate from your what is Euler path, what is Euler circuit, what is the Euler graph, right? Concentrate only for that. In the exam, they will give. If at all really definition required, they will give. What is the answer for this? You are very close. You are very close. You are very close. So can I give answer? Everyone given almost answer. Someone is saying that both not possible. Check one time. Check one time. Check one time. Someone is saying both not possible. Check one time. I'm giving answer. See the answer now? See the answer now? If you see the answer for this, Euler path and Euler circuit. Euler path and Euler circuit. So is Euler path is possible? No. Euler circuit is possible? No. Check one time. Answer is both not possible. How many of you both not possible? How many people say both not possible? Both not possible. If anyone say possible, please check. I given enough time. If anyone say possible, please let me know how possible. Someone saying that, sir, it is possible. Let me know. Let me know. Yeah, fine. Fine. I think how many examples I given? Now it is the correct time to go ahead. I think 3 examples only I given. I given 3 examples. I given 3 examples. So in the first one, yeah, I think, yeah, 3 examples are more than enough. From this, I want to give one conclusion. Very simple. You may be thinking it is a complex problem. Listen, you may be thinking it is a complex problem, but it is a very easy problem. Listen, it's a very easy problem. I'm writing now. See this one? Checking, see the note. Checking given graph is Euler graph or not. Checking given graph is Euler graph or not. Is a P class problem. Is a P class problem. P class means, remember, NP complete means difficult problem. P class problem means easy problem. Easy problem means it is not a undecidable problem. It is an easy problem. It will take very less time. That is the meaning. Checking given graph is Euler graph or not is a P class problem. P class means easy. Easy class. Easy class problem. Easy class problem. Some people are asking, sir, how, sir? Array man, very simple. That's what Raj is given. Raj is mentioned, right, a few minutes back. Sir, anything related to degree? Sir, anything related to vertices? I am giving the answer. Listen, I am giving the answer. Very simple, very simple. If you want, you can check this problem. Listen, if you want, you can check this problem. If you want, you can check this problem. In the given graph, every person contains even degree. Even degree means you can come also, you can go also. You can come also, you can go also. Means no stock. Here also, you can come also, you can go also. Here also, you can come also, you can go also. No stock. In the given graph, everyone is even degree. Euler path possible, Euler circuit also possible. No stock is possible. See this one? You started from here, right? You came here. You can go also. You came here. You can go also. You came from here. You can go everywhere. 2 choices. You can go also. You can come also. No stock is left out. In the given graph, every person is even degree. Euler path possible. Euler circuit possible. Given graph is Euler graph. Right? You have to check everyone is even degree or not. That is the reason it is a P class problem. P class means polynomial class. Less time. Every person degree you have to find out. You may say that, sir, how to find out every person degree? Sir, how to find out every person degree? Nothing there. Listen, you will ask all the neighbor, am I adjacent to you or not? You will ask every person, am I adjacent to you or not? You will ask you, am I adjacent to you or not? Means degree finding is nothing but asking all neighbors. Asking all the people. A will call everyone. A will ask, hello B, am I adjacent to you? Yes, degree 1 added. Hello C, am I adjacent or not? Yes, degree 1 more added. Hello E, am I adjacent to you or not? No. Hello, right? Hello G, am I adjacent to you or not? No. Hello D, am I adjacent to you? Like that they will ask, right? Asking everyone, right? What is the answer? V time, V time, V time, V time, V time, V time. Everywhere we like that V time. After asking everyone, I got to know what is my degree. I will divide myself by 2. If at all, it's a remainder is 0, even degree, otherwise odd degree. So finding a degree, V time. After finding degree, divide by 2. If remainder 0, even degree, otherwise odd degree, like that everywhere. Finding here degree, V time. After finding the degree by 2, even or odd. So if it is a 0 or even degree, so like that everywhere I have to do one scan. Everywhere v time, like that, right? V times you have to v square time. Time complexity to verify given graph is a Euler graph or not, simply order of v square time, because every person degree you have to calculate. Every person degree you have to calculate. Other than this, nothing. Asking everyone. So let's see, 5 people are there. I will ask myself, I will ask everyone, are you adjacent or not? Yes, then increment degree by 1. Are you adjacent or not? Yes, increment degree by 1. So asking everyone v time. Asking everyone v time. Asking everyone v time. Asking everyone v time. V times v square. Anyhow, you have to study this one, right? In maybe in algorithm. Anyhow, it is required, maybe in the data structure, right? So it's better to say here, I'm saying. Time complexity to verify given graph is Euler graph or not, time complexity order of v square, because every person is even degree. Euler graph, otherwise it is not Euler graph. Okay, fine. You got some idea? Can you come back? Listen, can you come back here? Interesting answer. Is it Euler graph? Easily you will get, I will give the note also, don't worry. Is it Euler graph? Problem number 1, is it Euler graph? Can you help me now? Problem number, Shiva saying that please explain time complexity using adjacency list. You calculate yourself, Bhaiya. Some people started now only. Some people started discrete mathematics now only. They will die. Adjacency list, adjacency matrix. So, Shiva, in my brain, so many calculations will run. If I say now, some people don't know what the adjacency list, what the adjacency matrix. So you know, already you know, please check yourself. Please check yourself, adjacency matrix, you know, adjacency list, you know, please verify accordingly. Right? Fine. I don't want to say so that some people will suffer. That is the reason I control. Otherwise, I want to go adjacency matrix this much, adjacency list this much. Right? So I want to go, but anyhow, it is the discrete mathematics. So that is the reason I control. Right? Whatever possible, simply instead of neglecting, I set rough idea. Checking given graph is a Euler graph or not, right? It's a P class problem. Means polynomial class problem. Means it is a decidable problem. It will take less time. How less time, sir? Simply asking everyone, your degree even or not. I am asking this person, your degree even or not. He said that I don't know my degree. Then calculate. How to calculate? Ask everyone. A will ask every person. So how much time? B time. After finding the degree, divide by 2, even or odd, which will take constant. So degree finding v, degree finding v, degree finding v, like that v times v square. Okay, that's okay. Everyone is even degree, so it is a Euler graph. Euler path possible, Euler circuit possible, so given graph is a Euler graph. Can you come here? Can you come here now? In this graph, everyone is even degree or not? In the first graph, everyone is even degree or not? In the first graph, every person is even degree or not? Make it fast. In the first graph, every person degree even or not? In the first person, every person degree even or not? If at all not even, if at all not even, it is not Euler graph. Just cancel first. It is not Euler. Every person even degree. No. Then cancel it first. Then cancel. It is not Euler graph. Next one. It is not Euler graph means Euler circuit is not possible. It is not Euler graph means Euler circuit is not possible. That's the meaning. At least Euler path possible. Very simple. Listen. At least Euler path possible. Very simple. Listen. If you want only listen. Euler graph is not satisfied means Euler circuit is not satisfied. At least Euler path satisfied. You have to check like this one. What the answer? Exactly 2 vertices odd degree possible or not check. Odd degree there, that is the reason it is not a Euler graph. Odd degree there, that is the reason it is not a Euler graph. Means it is not a Euler circuit. But how many odd degree? 2 odd degree? Exactly 2 odd degree? Yes. Then Euler path is possible to that path. One of the odd degree is a starting person. One of the odd degree is ending person. Suppose if you start from B. See, I started from B. One of the odd degree you start. I started from B. You will end up with another odd degree. When one odd degree also, Euler graph is failed. Means Euler circuit is failed. 1 odd degree also. Your graph fail, your circuit is fail. Next question. Then what about your paths are? Odd degree there, how many odd degree? 2, exactly 2, yes. Then to that your path, one of the odd degree starting, one of the odd degree ending. Means your path is possible. Starting point is 1 odd degree, ending point is 1 more odd degree. Do you believe or not? When I am solving this problem, I started initially with A. If you start initially with A, your path not possible. Odd degree you start. Because of odd degree, your graph is gone. Your circuit is gone. But how many odd degree? 2. Then what you do is, one of the odd degree you start. You will end up with 1 more odd degree. So your path is possible. So indirectly, directly here also degree checking required. Degree finding V time, degree finding V time, degree finding V time, everywhere V. Because you have to ask all the people. V times V, V square. Okay, that's okay. V square over. Now check everyone even or not. Is it even? No problem. Is it even? No problem. Is it right? Is it even? No problem. Is it even? No problem. Is it odd? Yes, yes. Wherever you see the odd, stop. Stop and say, your graph is gone. Your circuit is gone. Now immediately check how many odd. Is it odd? Yes. Is it odd? Yes. How many odd? 2. Oh, then Euler path is possible. To that Euler path, what is the starting point? 1 of the odd degree starting. What is the ending point? 1 more odd degree is ending. If you start other than those 2 people, definitely you may not find out the Euler path also. Now come back now. See the interesting answer. Can you see this problem? Can you see this problem? What is the degree? What is the degree? Odd degree. What is the degree? Odd degree. What is the degree? Odd degree. See, more than 2 vertices with odd degree. 1 odd degree, listen, 1 odd degree you see. Euler graph is gone. Euler circuit also gone. More than 2 vertices with odd degree. Right? Euler path also gone. More than 2 vertices with odd degree. Euler path gone. 1 odd degree also. Euler circuit is gone. Means Euler graph is gone. Careful. Can you write the note? You are perfect. In my opinion, you are perfect. Can you write the note? Note. In the given graph, note 1. In the given graph, all vertices with all vertices with even degree. With even degree. Then given graph is Euler graph. Because Euler circuit possible. Okay, 2. In the given graph, if one vertex also odd degree, then Euler circuit fails. If exactly 2 vertices with odd degree, then if exactly 2 vertices with odd degree, then Euler path possible. But not Euler circuit. Fine. 3. If graph contain more than 2 vertices with odd degree, with odd degree, then Euler path also not possible. Yeah, write all the things in your own lines. First, I explained without saying any theorem. First, I explained. I make sure you are comfortable with all. Now, right afterwards, I given what is the short way to do this. Just to check even degree or not. One odd degree also, not Euler. Exactly two vertices with odd degree. Exactly two. Euler path possible at least, but not Euler circuit. More than two vertices with odd degree. If graph contain more than two vertices with odd degree, then Euler path also not possible. It's a very, very important one. See, the problems whichever I given till now in this story, they all came in the examination. In the given graph, all vertices with even degree. All vertices, even degree. Euler graph, because Euler circuit. In the given graph, if one vertex also odd degree, if one vertex also odd degree, Euler circuit fails. Exactly two vertices with odd degree, Euler path possible, but not Euler circuit. If graph contain more than two vertices with odd degree, Euler path also not possible. Yeah, everything, whatever I want to say, I said. If you okay, I can proceed further. Are you comfortable now? Are you comfortable now? Now any problem you can handle. About the Euler, any problem you can handle. Right? How to find out time complexity? Every person degree, how to calculate? Degree means asking every person. Right? So you may say that, sir, it depends upon the how you represented a graph. True, right? You can do that work also. Adjacency list, how much, right? You find out yourself. You find out yourself. Those people who knows adjacency list, adjacency matrix, right? You can check yourself, right? I think that is the homework. If you want, you can write in your group. In your group, I will give the answer. So the homework is going to be, what is the time complexity to verify given graph is Euler graph or not, if the graph represented by adjacency matrix. Second question is adjacency list. Can you try that? That is a homework. Write yourself. Because of the discrete mathematics, I don't want to write here. You can write in your own way. Homework. Can you write one time? Homework. Homework. What is the time complexity to verify given graph is Euler graph or not? What is the time complexity to verify given graph is Euler graph or not? Right? 1, using adjacency, right? Using adjacency matrix. 2, using adjacency list. Shiva, write that. Shiva, write that. Right? In the group, you can write. I will give the answer. You please discuss yourself. Right? I will also participate. Because it's not a good idea. Discrete mathematics writing time complexity. Right? It's not a good idea. Okay, fine. You are okay now. Now, in one of your previous paper, one question given, I am writing now. Are you really comfortable or not? Check. Write down. Which one of the following graph is Euler graph? It's one of the previous paper question. Let's check. Will you give answer or not? In my opinion, everyone will give wrong answer. Which one of the following is Euler graph? Mostly, in my opinion, everyone will give wrong answer. Let's check. Yeah. Option A. Every K regular graph where K is even. That is the option A. Option B, complete graph on 90 vertices. Option C, complement of a cyclic graph. Complement of cyclic graph on 25 vertices, C20. Complement of cyclic graph with 25 vertices, C25. D, none. Yeah, try to give answer. Anyhow, just leave it. Just leave it. Now concentrate here. Fine. Just leave it. Let's concentrate here. So this is the place where we stopped yesterday. This is the place where we stopped yesterday. Are you okay with this problem? Which is the answer? What is the correct answer? Correct answer, C. If anyone still doubt, let me check. In the place of C25, let me take some small number. Right? It's the odd number. Let's take some odd number. Let's take some other odd number. C5 I am taking. So 5 vertices. C5 I am taking 5 vertices. Yeah, I think internet okay, everything fine. 4, oh, let me keep 5. You may get some interruption. Can we go ahead? Is it okay now? I changed 4G to 5G. I done 4G to 5G. Is it okay? Any problem? Hello? Hello? Any problem? No problem, na? No issue, na? Okay, let's come. Let's come then. Now see. So C5, C25, which is the odd number. So C5 also odd number. Now, when you say cyclic graph, it is like this. Now, when you say complement of cyclic graph means whatever they remove, remaining things keep. Remaining in the complete graph, remaining. These are the things. In the complete graph remaining, these are the things. So can you help? Totally C5 contain, right, 5 into 4, 20 by 2, 10 people. Outside 5, inside 5. This is. So every person degrees, right? Actually, when you say C5, every person, right? When you say C5, normally K5, every person degree 4. K5 means every person degree 4. When you say C5, every person degree is 2. So from the 4, remove 2. 4 minus 2. So everyone degree 2. Is it fine? K5 means everyone degree 4. C5 means everyone degree 2. Right? From the 4, remove 2. So everyone degree 2, which is even. Right? Similar way, K25. Everyone degree is 24. Right? C25. Everyone degree 2. 24 minus 2. 22. 22 is an even number. Be careful. So complement of C25, which is going to be C20, which is going to be everyone degree 22, which is the even number. So option C, right? Everyone know. So every K regular graph, many people thought that A is the answer. In this problem, twist is option A only. Option A only. K regular graph, where K is even. Everyone think that, oh, every person is even. But one line is missing. Connected keyword is missing. So I give an example also yesterday. So this may be the answer for this. Everyone degree even. every 1 degree even, right? But unfortunately, there is no path. There is no path which will cover all the people exactly once. Starting vertex is equal to ending vertex. No path like that. K90 means every 1 degree is 89, which is the odd number. So answer is that, right? So if at all this question is given MSQ, everyone could have given wrong answer. If at all this question is given as MSQ, everyone could have given wrong answer. Am I right? Am I right? If at all MSQ, everyone wrong. Everyone wrong. And one more thing is, you can avoid many mistakes. If you can avoid many mistakes, if you do these kind of problems before exam. Before exam, if you do this kind of problem, in examination, one of the thing will repeat. What you will do is, whatever there in the previous PYQs, right? You will mix two problems as one problem. You will make one problem as two problems. You will add the same problem by adding one condition, right? You will add the same condition, same problem you will add, input becomes output, output become input. Some changes you will do. So please do class notes. Class notes, most probably, many problems will be covered, right? Afterwards, do weekly tests. Don't postpone anything to last. No one knows what will happen at last. No one knows. If you do early, most of the problem solution is early. Make it early so that problem become very easy. So whenever we are discussing in the programming, static scoping, dynamic scoping, can you say which one is difficult? In the programming, those people who attended the programming, static scoping, dynamic scoping, which one is difficult? Dynamic, right? When you delay running time, many problems will come. If you solve that problem compile time itself, then it will become easy, right? Early, if you do, most of the things are easy. Early, if you do. So if you want to be a winner anywhere, whatever profession you want to select, because of you are a kid, I am saying now itself, I am confirming, right? Do everything early, right? Easily will go to the top place. The people who will do always late, they don't achieve anything in their life. Do early, everything do early. Everything do early, but don't do blindly, early do. Oh, there is some work you want to do next month, do this month only. There is one work you want to do next week, do this week only. Instead of next, do now. Don't do now as next, do next as now. It will become very simple. Okay, fine, this is perfect. Let's go to next one. I'm thinking that until now everyone is. Let's go to next. Everyone observe. Right, I am giving, I think I will go to the previous problems only. No need to write again and again. Let's see the previous problem. This one. The first problem. Interesting answer. Is it Euler graph? Confirm. Is it Euler graph? Yesterday we done. Please check yourself. See, yesterday the story is so difficult. Now it's very easy to you. Yesterday, this is so difficult. See, the things which are difficult yesterday, they are so easy now. Life is always like this. I'm saying to you, life is always like this. Today difficult, right? Tomorrow easy. If you don't try every day difficult. I seen one student from last 2 years. He's saying to me, Reddy sir, I want to study, right? Reddy sir, I want to study from you. 2 years onwards. 2 years is not starting. Every day, whenever I will send any message, he will reply, right? I will start GATE preparation soon. He is not starting. So if you don't start, it never move. Remember. So just start and finish it off. Right? Now, can you help me now? This graph is Euler graph or not? Yesterday, it is so difficult. Now, please let me know. You can easily say this. Is it Euler path possible? You know there is a shortcut also. Euler path possible. Even degree or not verify yaar. Everyone even degree. Everyone even degree. Everyone even degree. No, because of everyone is not even degree. Euler graph is gone. Euler graph is gone. Right? Because exactly 2 vertices with odd degree. Exactly 2 vertices with odd degree. What is the answer? Euler path possible. Euler circuit is not possible. So given graph is not a Euler graph. Now see the beauty. Now see the beauty. Everyone listen. Everyone now see the beauty. Can you help me now? Forget about edges. Interesting answer. Forget about edges. Can you help me now? Is there any way to cover all vertices exactly once? And starting vertex is equal to ending vertex? Is there any path every vertex is exactly once? Forget about edges. You can leave some edges, no problem. You can leave some edges, no problem. Is there any path where every vertex will be covered exactly once? That is called a Hamiltonian. Now listen, every vertex is covered exactly once. Yes, that is called Hamiltonian path. There is a path which cover all vertices exactly once. Okay, Hamiltonian path. To that path, starting vertex is equal to ending vertex. Then that is going to be Hamiltonian cycle. It is not circuit, here cycle. Some terminology differ. So Euler circuit, Hamiltonian cycle. Cycle. Then I can say given graph is a Hamiltonian graph. Remember, Hamiltonian cycle possible. Then it is a Hamiltonian graph. Hamiltonian. Given graph is Hamiltonian graph. Just check Hamiltonian path or not. Yes. Hamiltonian cycle or not. Yes. Then the given graph is Hamiltonian graph. Remember, in the Hamiltonian cycle, every vertex will be visited exactly once. Starting vertex is equal to ending vertex. Exception. Because otherwise, how cycle possible? Otherwise, how cycle possible? You only say. Can you write that point also? First, write the point. Then you can take that example. Write that point also. Just wait once. Why some messages are popping up? 1 minute. Yeah, fine, perfect. Now it's okay. Let's see. Now also will come. Now see the definition. See the definition. In the given graph, if you find a path, where each vertex covered exactly once, then we can say given graph contain Hamiltonian path. You can write whatever way you want. Just I written roughly. In the given, right? In the given graph, if you find a path, if you find at least one path, if you want, you can write, if you find at least one path, if you find at least one path, there may be many paths. If you find at least one path where each vertex covered exactly once, then we say given graph contain Hamiltonian path. Okay, perfect. If you want to compress, compress. If you want to expand, expand. Just I want to give idea one time I give. Next, see the one more point. See the one more point. See the one more point. If you find at least one Hamiltonian path and to that path starting vertex is equal to ending vertex, then we can say Hamiltonian cycle also possible. If you find at least one Hamiltonian path and to that path starting vertex is equal to ending vertex, then we can say Hamiltonian cycle also possible. Again some pop-up going on. Anything sound came? Right, next one. Let me write now. If graph contain at least one Hamiltonian cycle, then given graph is Hamiltonian graph. If graph contain at least one Hamiltonian cycle, then given graph is Hamiltonian graph. Are you okay these 3 points? Are you okay these 3 points? I'm really saying, if you open any book, they will kill you. They don't know what they are talking also. They will say walk, they will say geek, they will say path, they will kill you. They will say trail, they will say nonsense. Array, whatever nonsense they want, they will talk. If you open book, you don't know what they will talk. What they will talk, you don't know. So, right? One book will say trail, one book will say walk, one book will say running. Right? They will say whatever they want. Final point is this only. They will give one graph, they will ask you, given graph is Euler graph or not? Given graph is Hamiltonian graph or not? Right? If at all kid is teaching, kid will teach everything here. If at all same topic kid is teaching, kid will start. What is the difference between walk, trail, running, sleeping? Everything they will teach. Everything. Yeah. If you read Coreman, over. Right? Coreman you read over. Not only Coreman, open. Right? For the graph theory purpose, one book there. Graph theory. Right? Introduction to graph theory by Narsingh Dev. There is one book there which contains 300 pages. 300 pages for only graph theory. Study and die. Study graph theory, right? By that book, right? Die. Right? You will say total, right? Hamiltonian and Euler, right? They will write the Bhagavad Gita. What is Hamiltonian? What is this? Why it came? And all the things they will say. Just it's very simple. How to verify given graph is a Euler graph or not? How to verify Hamiltonian graph or not? Now some people are asking, sir, can you read this? I read. See, I already said to you, can't you write in your own way? Can't you write in your own way? Who asked you to copy as it is mine? In the given graph, if you find at least one path where each vertex covered exactly once, then we can say given graph contain Hamiltonian path. If you find at least one Hamiltonian path and to that path starting vertex is equal to ending vertex, then we can say that Hamiltonian cycle also possible. If graph contain at least one Hamiltonian cycle, then given graph is a Hamiltonian graph. Right? Whatever way you like. See, you understand. You understood. Why don't you write your own way? See, the people who will write their own way, you are a creative person. Are you getting? You are a creative person. That is the way how creativeness will start. Creativeness will start like that. Sir, if I want to do some creativity, I have to go to Goa, I have to sit in the beach, then I have to take one notes, I have to take one pen. In the Goa beach, I will sleep and I will start thinking, array buffoon. It is not the way. Whenever teacher is saying, write in your own way. Write your own way. Shakir is saying it's a good idea. Okay, you go to Goa beach and right, you sleep there and you keep on thinking. GATE exam, who will write? Papa will write. GATE exam, Papa will write. Mama will write. Mama, Papa will write. Who will write GATE exam? Mama, Papa, you write the GATE exam. I am going to the Goa. In Goa beach, I will think. In Goa beach, I will think. He's saying that good idea. Okay, go beach. Go. In Goa beach, all beggars are there. Go and sit there. So some people are thinking, sir, if I want creativity, should I go Kerala and should I think about it? Should I go to Kerala and should I think about all the beaches? Can I roam? Or can I go to Goa? Array man, whenever teacher is saying, write in your own way. Oh, this is the Hamiltonian. Right? Okay, I have to find a path, at least one path, where every vertex will be covered exactly once. So write whatever you want. Write whatever way you want. Write nicely, so that, see, I think after 2 days, if you ask me, sir, can you read this? No one knows. Sometimes I cannot read my own things. In the given graph, what is this? Who knows that it is a graph? Sometimes I cannot read my own. I used to feel so sorry by myself. In the given graph, this is the graph. Who said it is a graph here? Who said? In the given graph, if you find at least one path where each vertex, what is this? Covered. Okay. Exactly once, then we can say given graph contain. It is a contain. It is a contain. Contain continuously, all are same. Graph contain Hamiltonian path. Thank God I am not a doctor. If I am a doctor, dead. Ashwini Sharma. I will write Ashwini Sharma. Over. If I am a doctor, over. This is the Ashwini Sharma. This is the Ashwini Sharma. If I am a doctor, right, I will show help to the patients. Sir, give one problem and discuss. Right? Fine. So many times my check is bounced. My check bounced back because my sign is not matching. My sign is not matching so many times, right? So many times my check is bounced because I cannot write my own sign. I created that much nonsense, right? Like so lazily I written. I cannot write my own sign. Even I don't know how I written. Same, right? I think anyhow, leave this. See, one dog came, that dog is barking. Just one dog came, that dog was, sir, give one problem and discuss. Array dog, class is 5:30. You came at 6:30 and you are asking one problem. Like a small puppy, see, like he came at 5:30, 5:25 only joined. See how he's asking, sir, can you give one problem and discuss? Like a small puppy. Right? Shiva puppy. Name is called Shiva puppy. Hello, puppy Shiva or Shiva puppy? I don't know. Right. What is SV? What is EV? God knows. Bhaiya, God knows. What is SV? What is EV? Yeah, right? SV and EV. Yeah, both are minus. This minus is very, very important. Both are minus. S minus V is equal to E minus V. Both are minus. EV are electric vehicles. Electric vehicles. Right? Fine. Let's come to the problem. Right? Again it will come. So we'll see one more time. Again, right? We'll see this. Can you come back? Can you finish it off? Can you finish it off? In the second problem, this problem. Please can you verify? Is it Hamiltonian graph? Those people who are not getting what is happened till now, can you verify this Hamiltonian graph or not? Can you verify is it Hamiltonian graph or not? I'm expecting answer. Let's see how many people will do. Hamiltonian graph. Right? Can you find a path where every vertex is covered exactly once? You cannot repeat the vertex. Arey Shiva, class is at 5:30. How can you come, Shiva? How can you come at 7 o'clock? How can you come at 6:30? Class is 5:30. You came at 7 o'clock. How can you come like this? We are waited. He didn't said sorry also. See the interesting thing. He didn't said sorry also. Sorry also not there. Sorry also. So it's killing me. So problem is Algo. I have listened. I don't know what he's talking. I need to manage time. That's okay, Bhaiya. But class 5:30 na. Class 5:30 na. You only said yesterday. Yes, yesterday you said okay 5:30. Arey, we waited. You could have said I cannot attend. Arey, you came at 5. You said you came at 6:30 or 7 o'clock. He came at 7 o'clock. What is the time now? Yeah. Oh, 6:15. Okay. I thought he came at 7 o'clock. Just visiting professor. I attended, sir. And after some time I will go. Okay. Chalo then. Now see, everyone give the answer. What is the answer of this problem? What is the answer of this problem? What is the answer of this problem? At least a Hamiltonian path possible. At least a Hamiltonian path possible. Hamiltonian path possible. Now see this one. I think say remember vertex cannot repeat. Starting vertex, ending vertex can repeat, but intermediately. See this one. You want to cover all vertices one time. See this one. All vertices one time. You came like this. You came like this. You came like this. But these two people inside, two people are there. You want to cover them. Listen, to cover them, you went like this. When you are going like this, you will touch this. Same person you will see. Same person you will see. When you go here, same person. So you may say that, sir, can I do this? Can I do this? You may say that, can I see this? Sir, I will do like this, then what is the problem? So some students are saying, I will do like this, sir. See the answer? I will do like, sir, I will come like this. Okay, come. Okay, come. This vertex is laughing. This vertex is laughing. Arey Shiva, you cannot cover me. This vertex 8 is laughing. Arey Shiva, shameless fellow, you cannot cover me. Then can I go inside? Can I go inside? This vertex 8 is crying, saying that you cannot cover me. Right? So I think you cannot go inside. You cannot go inside. If you go inside, the guarantee this vertex will touch. So you do whatever you want. So Hamiltonian path also not possible. If Hamiltonian path not there, there is no meaning of Hamiltonian cycle. There is no meaning of Hamiltonian graph. Okay, fine. Because of you are almost okay. Can you see the next problem also? Can you see next problem also? Remember, you have to push up yourself. Topic by topic you have to go. Topic by topic. If topics will be keep on over again and again. This topic over, that topic over. If you do that, then only you are a winner. If you stuck at some place, you cannot be a winner. You have to move the things. You have to move the things. Oh, this topic is troubling. Just keep it aside. Then go to the next topic. If it are completely different, happily you can go ahead. I don't want to listen from you. Sir, this subject I am not okay. Don't say superset here. This subject not okay. Don't say like this. This subject not okay. GATE syllabus not okay. Don't say like this. Which problem not okay? Which topic not okay? Please talk small things. Don't talk big lines. Now can you come here now? To this problem yesterday we done. See this one, odd degree. So more than 2 vertices with odd degree. Euler path not possible. Euler circuit not possible. Given graph is Euler. That is also failed. Now see the Hamiltonian. What about Hamiltonian path? What about Hamiltonian cycle? What about Hamiltonian graph? Let's check. Let's check everyone. I think it is a very bacha problem. It is a very bacha problem. I think you can go directly or not. It is a bacha problem. Can you go directly or not? One nice walk. One nice walk. Hamiltonian path possible, Hamiltonian cycle possible. So given graph is a Hamiltonian graph. Fine. Yeah, come to here. I will give some more problems. Can you see this? What about this? I want answer. I want both the answers. Is it Euler or not? Hamiltonian or not? Verify. Verify this. Is it Euler or not? Is it Hamiltonian or not? And one more problem. Yeah. Try this also. Is it Euler graph or not? Is it a Hamiltonian graph or not? Is it Euler graph or not? Is it Hamiltonian graph or not? And one more problem. It doesn't matter how much talented you are. Some people thinking, sir, I am talented, I will get the rank, sir. GATE don't care how much talented you are. GATE exam don't care how much talented you are. It never bother about how much talented you are. Simply two things are there. You completed syllabus or not? Yes. You done the practice or not? Yes. That's it. Sir, my BTech percentage is 90. I will go to IIT. Just stop. Bakwas. Right? Bakwas baat band karo. Sir, I am topper in the college. I will get the very good GATE rank. Just stop. Sir, I am the very dull student. I failed already. Can I get the GATE rank? GATE rank don't bother anything about your past. I am 80 percentage. I am 70. I am 60. It doesn't matter. Just, are you completed syllabus or not? Yes. Next, are you done practice or not? Yes. That's it. Do this, you are going to be the winner. Yeah. Can you complete this? Sir, I'm job going, sir. Ready, sir, I'm job going, sir. GATE exam don't care. Simply don't care. I have less time. It don't care. Sir, I am student. I have more time, sir. It don't care anyone. You want to get good GATE rank? Complete syllabus. Do practice. This is the only thing which can save. These three people, please complete. Which is Euler, which is Hamiltonian. Complete once. You don't know. GATE exam is 4 more months. How many people will come live? You don't know. You can't imagine how many people will come live. GATE exam is 4 more months, 5 more months. Many people will come live. You can't imagine. That time, many doubts they will ask. First one, Euler. First one is Euler graph. I think the problem with this person is odd degree. The person, this is one odd degree. One more odd degree there. No. So Euler graph, Euler path also not possible. Exactly 2 vertices with the odd degree required. Is it odd degree? Sorry for this one. Is it odd degree? Let's check. Exactly 2 vertices with odd degree. If you start with one odd degree, you will end up with one more odd degree, of course. Euler path possible because of odd degree. Exactly two vertices with odd degree. So Euler path possible. But Euler circuit, right? Euler circuit is not possible. So given graph is not Euler graph. Let's go to Hamiltonian. I think Hamiltonian, I think can you observe this? Can you observe this one? Hamiltonian. Hamiltonian. One nice walk. See this one. One nice walk, you will go like this. One nice walk, you will go. Can you help me know? Is it Hamiltonian path? Yes. Hamiltonian path? Yes. Hamiltonian cycle possible. Hamiltonian cycle possible. Path possible, okay. Covering all vertices once. Is there any chance of cycle? Starting vertex is equal to ending vertex. It's not. So given graph is not Hamiltonian graph. So first one, neither Hamiltonian nor Euler. Am I right? First one, neither Hamiltonian nor Euler. Is it okay? First one, neither Hamiltonian nor Euler. Fine. Let's go to second. Let's go to second. Second one, if you observe, see this one, it is the odd degree. It is also odd degree. More than two vertices with odd degree. Euler graph, both gone. Euler graph, both gone. Let's go to Hamiltonian. Let's go to Hamiltonian. Let's check Hamiltonian. Let's check Hamiltonian. Everyone listen. Covering all the people. See this one, covering all. Can I cover like this? Am I right? All people covered. Check. One nice path. One nice walk, covering all people, saying everyone hi. Hi Shiva, hi Raz, hi, what else? Hi Ashwini, hi Jaya. So just saying hi to everyone. Finally, I am saying hi to myself. Hi Reddy. Right? First I said myself. I just going by walk everyone. I'm saying hi Shiva, hi Raz, hi Gayatri, hi Jaya, hi Ashwini, something like that. Hi Sayan, something like this. I said to finally myself. So finally, so given graph is a right Hamiltonian path possible? Yes. Hamiltonian cycle possible? Yes. So given graph is a Hamiltonian graph. Fine. Missed my name twice. Okay, two times I will say. Hi Hayden, hi Hayden. Are you happy now? Two times I said. Hi Hayden, hi Hayden, hi Hayden. Three times also I done. Thank you, shameless fellow. No shame also. Can you come here? Can you come here now? What about the last diagram? What about last diagram? Is it a Hamiltonian graph? Is it a Hamiltonian graph? See this one. More than two vertices with odd degree. More than two vertices with odd degree. And right, I think Euler graph is failed. What about Hamiltonian? What about Hamiltonian? I think there is no chance. Because definitely repetition will be there. You cannot cover, see this one. If you listen correctly now. If you cover this one, you cannot cover this. If you cover this one, you cannot cover this. If you cover this, you cannot cover this. If you cover this one, you cannot cover this. I think Hamiltonian path also not possible. Check. Forget about Hamiltonian cycle. So given graph is not Hamiltonian. Is it okay? Is it fine? Someone is saying Euler path possible. Euler path possible. Euler path possible. More than two vertices with odd degree. Oh, it is an even degree. Oh, it is an even degree. I thought it is odd degree. Even degree. Yeah, possible. Right? Exactly two vertices. Right? Exactly two vertices with odd degree. Exactly two vertices with odd degree. I thought it is an even degree. Right? I thought it is odd degree. That is the reason I thought. So anyhow, let's go here. Let's go here. Right? So I will start from here. Because vertex you can repeat. Exactly two vertices with odd degree. So Hamiltonian path possible. Sorry, right? Euler path possible. but Euler circuit is not possible. Hamiltonian path, no way. So Euler is very simple. Euler is very simple, but try to understand everyone. Everyone try to understand. Careful, careful. Everyone try to understand. Right? Everyone try to understand. There is no algorithm for Hamiltonian. Like Euler, Hamiltonian don't have any algorithm. It's very simple also. Just walking. Don't cover the same vertex many times. Cover every vertex exactly one time. This is also one of the NP complete problem. Checking, given a graph, checking given a graph, Hamiltonian or not. Or not. Is an NPC problem. NPC means listen, NP complete. That means completely toughest problem. Completely toughest problem. That is the meaning. Checking given a graph Hamiltonian or not is a completely toughest problem because no algorithm. No algorithm. Other than brute force, other than checking manually, one by one, right? They tried many ways. If anyone says, sir, I have one algorithm, please let me know. Sir, I have one algorithm to verify given a graph is a Hamiltonian or not. Please let me know, so we'll check that also. Checking given a graph Hamiltonian or not is an NPC problem. No algorithm. NPC means NP complete problem. Next one. Checking given a graph, Euler or not. Yesterday I said to you, Euler or not. What is the answer? It is a Euler or not. It is a P class problem. P class means polynomial class. P class means polynomial class. Polynomial class. When you say P class, polynomial class means easy problem. Easy problem. Because the time complexity yesterday we discussed also order of V squared for matrix, adjacency matrix, depending upon how you represent graph. Depending upon how you represent graph, right? Because of right, yesterday I given some hint also. You can see this. Listen, graph will be represented by matrix also, list also. See this one in the matrix. In the matrix, this one. Vertex 1 here, vertex 2 here, vertex 3. Vertex 1 degree, if you want to find out total row, you have to scan V time. Vertex 2 degree, if you want to find out total row, you have to scan V time. Vertex 3 degree, if you want to find a total row, you have to scan V time. V times V, V times V, V square. Graph is represented in the form of a adjacency matrix. So for the Euler checking given graph is Euler or not, right? Order of V square. Some people are asking, sir, what about list, sir? List will be like this. List will be like this. That is the reason I said before only the things which are required. Please complete. Please push algorithm and DS. Push algo and DS. You cannot escape. You cannot escape. That is the reason I done starting only. These two people you cannot escape. You go any subject, indirectly, directly, they will come. Or right in your life itself, they will come. If you want to get a job, those two required. Right? If anyone says, sir, I am not okay with algo DS, become okay. That is the only way. Just become okay. That is the only way. Sir, I'm not getting algo, sir. You are not getting? Okay. Make it okay. Sir, I am not okay for algo, sir. Make it okay. Yeah. No other way. If some other way there, right? I also tried to escape algo DS initial days. When I'm studying BTech, that time also, I tried my level best to escape. And wherever I go, right? You want to get a job, DSA required. You want to get that what? That right? DS required. Wherever you go, people are asking. I fed up of myself, so I started preparing. Now see this one. See correctly? Adjacency list. For the vertex 1, whoever adjacent, all are there in the form of a linked list. Vertex 1, whoever adjacent, all are there in the form of a, right? Like this. In the form of linked list, they will be available. They will be available. These are, I think, outside. Linked list is edges. Linked list is edges. Linked list is edges. I think for these people, right? If you want to visit this list, you have to visit like this. What is the answer? First you have to visit vertex followed by this, right? This one, vertex followed by this, vertex followed by this, vertex followed by this. These all will leads to E, edges. These all leads to vertices. Totally you covered vertices, edges one time. V plus E. V plus E. So answer is order of V plus E. Okay? Can anyone guess? Can anyone guess? If it is a complete graph, what is the E value? If it is complete graph, what is the E value? Very interesting answer. Complete graph, what is the E value? What is the answer? V into V minus 1 by 2. Sir, in 1 month you covered Algo and TOC both. Yeah, morning one, evening one I covered. Like that, but it's fine, right? It's fine, right? Cyan, you push whatever way possible. Come here in the middle you ask. Can you help me? If it is a complete graph, how many edges? How many edges I'm asking? I'm not asking degree. Complete graph, how many edges? What is the answer? N into N minus 1 by 2. Am I right? Kn. N into N minus 1 by 2. In the place of N, write V. V into V minus 1 by 2. Forget about constant. If it is a complete graph, this became V squared. So V squared plus V, it will become V squared. Whoever bigger you take. V plus V squared, so V squared. So last time I want to ask you, if it is a null graph, what is the E value? Null graph, what is the E value? 0. If null graph E value 0, just keep the E place 0, then V will come. Right? One student asking me in the group, right? In the group, one student asking me, why are you writing V? Who knows who is bigger? Actual answer is V plus E. Who knows who is bigger? V may be bigger. Whoever bigger you take. If at all null graph, V bigger. If it is a complete graph, E bigger. Whoever bigger you take. If you don't know who is bigger, keep both. I don't know, then I can see total 1 scan required. Right? Vertices also I have to scan, edges also I have to scan. All people covering B plus C. Whoever bigger you take. If you don't know who is bigger, keep both. Right? If you don't know both, just right. If you don't know who is bigger, keep both. Fine. So can you help me know? Checking given graph is Euler graph or not? Matrix is V square. List is going to be order of V plus C. Right? Fine. That's okay. It is not a big deal. So just complete Algo DS, right? Just come back here. You will get, right? If anyone has small doubt, write in your notes also. This one, it is based on, right? It is based on, right? Graph representations. In Algo, one of the top, one day we covered. Almost one class we done this. I given many different examples also. Graph representations. Right? Before going to start approximately, right? Prim's algorithm, Kruskal algorithm, I covered in one class. Right? Let's have a look at this. Okay, fine. Can we move further? Hamiltonian also okay. Remember Hamiltonian checking. No algorithm, no shortcut. Euler, right? There is a shortcut. Right? Shortcut possible means, I think P class problem. Shortcut is not there means, oh, brute force only. NP complete problem. And like graph coloring also NP complete problem. Two graphs are isomorphic or not. That is also no proper algorithm. You have to check every possible combination. Most of the graph problems are NP complete. Two graphs are isomorphic or not, NP complete. Chromatic number finding, NP complete. NP complete. Right? So careful. Planarity also NP complete. Okay, fine. That's okay. Come here. So normally they don't ask anything like that. Simply they will be one graph, small graph. If you take big problem, we cannot say. Small problem, we can say. Right? Whatever possible, they will give in the exam. But safe side, you remember, checking two graphs are isomorphic or not, NP complete. Right? Hamiltonian or not, NP complete. Chromatic number, NP complete. So most of the graph problems are NP complete. One of the graph problem which is not NP complete. Can you say which is easy? One of the graph problem which is easy. Can you remember? One of the graph problem which is easy. Can you remember? I'm repeating once again. One of the graph problem which is easy. Euler, right? Euler is going to be easy one, right? Because time complexity matrix is V square, list is V plus E, right? Okay, perfect. Perfect now. DS, I think 1 or 2 class left out. Yeah, I covered wherever possibility there, I done. Cyan, wherever possibility there, I done. Now come here. Come here. Come here now. I think, in my opinion, I done. One more problem is there. It may be bigger problem. It may be bigger problem. I will copy problem. Right? Can you also copy? It may be bigger. It may be bigger. Take this. This problem also you can handle, means most of the things you can handle. Don't see with eyes. It became so difficult, sir. This much bigger one we will do. Don't see with eyes. Just to follow calculations. Can you go ahead? Yeah, can you go ahead? Don't think much. See, if it is difficult, always you have to think like this one. Keep your 200%. Oh, it is a really difficult one for all same. You have to always think like this one. Is it difficult? Oh, it is so difficult. Immediately remember. Immediately remember. For everyone same, na? Let me keep my best. Whatever possible you do. If you thinking it is difficult, for everyone same. But within those 2 minutes, how to handle it? Within those 3 minutes, because every problem you have only 3 minutes. Given any problem in GATE examination means it will take 3 minutes only. Maybe some concept you forgotten that maybe looks like so difficult. Maybe you are not done practice. That may be reason. It may be look like difficult. If any problem really difficult for all the people same, no need to waste your time. Half an hour checking in the GATE exam on one problem, it is not a good idea. Check whatever possible. There is no algorithm for a Hamiltonian other than manually checking. Can you find a path where every vertex is covered exactly once? Yeah. Is it Euler? Is it Euler? More than 2 odd degree. So Euler path also not possible. Euler circuit also not possible. It is a odd degree. It is a odd degree. It is a odd degree. Okay, fine. Euler is very simple because shortcut there. What about Hamiltonian? Can you see this one? Can you see interesting one? Can you see the interesting one? Can you see the interesting one? See everyone. I find out already one path. See this one. Every person you have to cover one time. See this. See correctly. Over. I am at here. I stuck here. Any other way you will find out. Let's see. Let's see this one. See everyone. Is it psi A? Is it psi A? Just checking manually. I am not done anything. Psi A means what? Psi means okay. Yeah, see, I am Hindi professor, ask me. Eden Bhaiya, I am a Hindi professor, you ask me. If you learn my Hindi, you will die. If you learn Hindi from me, you will die. Life become ulta. Life become ulta. My madam saying, if you talk Hindi one more line, you don't get food also. If you get Hindi one more line, if you kill my language one more time, you don't get food also. So what should I do? Okay, I said Sai A. Yeah, is it okay? Is it okay? Can we move next? I don't know Hindi. I know or what? I know or what? Just I am talking here. Whatever I feel I am talking. Sir, in your 15 years, you always teach in English. No Hindi. Chup karo. Arey Shiva, chup karo. Chup karo. Because GATE exam in English, why should I teach in Hindi? GATE exam in English, na? Why should I teach in Hindi? यार? डिवाइड एंड कांकर में क्या बोलना हिंदी में डिवाइड एंड कांकर क्या बोलना है यार? डायनेमिक प्रोग्रामिंग हिंदी में क्या बोलना? डायनेमिक प्रोग्रामिंग हिंदी में क्या बोलना? रिकरेंस रिलेशन हिंदी में क्या बोलना? Right? Fine. It's okay. Fine. Different people will teach different ways. That's okay. Can we move next? Because in the question paper also, everything you see, every question is in English only. Every question is in English only, especially in the software industry. Every day you have to speak in English only. My request to everyone, whatever English you know, please type in the chat box. Please start slowly. Sir, I don't know English, sir. I don't know. Slowly, little bit type. Little bit type. Otherwise, you never grow. In the computer science industry, you will never grow if you don't know English. Please add little bit of English. Little bit. Then you will get the very good recognition. You will get the increments also so easily. Increments also you will get so easily. Please, can you push yourself a little bit? Yeah, I think that's fine now. It is a Hamiltonian graph. Can I move to next? Can I move to next? Without English also you can survive, no problem. But everything having their own consequences. Sir, without English, can't I survive in the software industry? You may not get job because in the computer science interview, let us assume you are unlucky. Let us assume you are unlucky. The person who came to the interview, you don't know Hindi. You know some other language. What you do? In the interview, right? The person who is there in the interview, you don't know Hindi, right? You went to one of the company interview, right? So in the interview going on, that person who is taking interview, you don't know Hindi, you know only English. What you do? So please practice a little bit. Don't leave everything to God. Right? Fine. Many times you will face this problem. And one more beautiful thing I want to say to you. See this one. One more beautiful thing I want to say to you. From last 15 years I'm teaching. I'm in Delhi only. Right? Last 15 years I'm teaching. I'm in Delhi only. I'm in Delhi only. Last 15 years I'm teaching. Total crowd is Hindi crowd. But still I am teaching in English only. Reason is software industry demands English. Software industry demands English. So that is the reason I never faced any problem. Because CSE people really need it. In other branches, can I help you know? Other branches, what jobs are available? Other branches, what jobs are available? Only government jobs? Other branches, what jobs are available? Only government? Other branches are only government, but software industry, computer science especially, every software industry needed English. So please can you push little bit? Whatever you know, you type in the chat. After a few days, everything okay. After a few days, everything okay. I forced every student so that they will learn English. They will learn English slowly. If you don't push, nothing will happen in life. Okay, you don't know this, so push it yourself. Right? Fine. I will talk only with my students. I don't talk with anyone. So I don't know, right? I don't need Hindi also. So that is the reason I am not that much fluent in Hindi also. I will talk only with my students. Class over, maximum doubts are there. That is also in English only. So I didn't get that opportunity to talk in Hindi. Okay, anyhow, let's leave this. Can we move to next? Let's leave this. Can we move to next? Everyone, can we move to this? Next. Can we go next? Yeah, fine. Now give the answer to me. Give the answer now. K4. Next problem. K4 contain how many Hamiltonian cycles? In one of the previous paper, this question there. K4 contain how many Hamiltonian cycles? It is a K4. Give answer. K4 contain how many Hamiltonian cycles? I want answer from you. How many? Can anyone guess? At least can you guess? You know what is Hamiltonian. You know what is Hamiltonian cycle. Remember everyone. One Hamiltonian cycle to another Hamiltonian cycle, at least one edge should be differ. At least one edge should be differ. You cannot take the same edge again. All edges as it is. Then how that is different? Yeah. At least one edge should be differ. That's what I am saying. At least one edge should be differ. At least one edge. If all edges are same, then they both are equal. When you say cycle, how order matters? All will come anyhow. When you say cycle, how order matters? Same cycle you cannot count 5 times. Same cycle you cannot count 5 times. Let me try. Let me try answer. See this? See this answer? Is it 1? V2, V1, V3, V4. So if you want, I will give edge numbers also. E1, E2, E3, E4. Okay, fine. So see this one. If you take anything where all these 4 people are there, that is same only. That is same only. Okay, I already covered. Okay, next. Next, see inside some edges are there. Inside some edges you have to cover. Let me cover this. Can you see, is it Hamiltonian? Is it Hamiltonian? And let me check. I will go like this. I will come like this, and like this. Is it okay? Is it fine? Something differ. Something differ. So I will give the edge numbers also. E5, E6. Totally 6 edges. Let me write now. V3, V2, V1, V4, V3. If you see the edges, the E6, E5, E3. See, something differ. Something differ. Is it okay till now? Something differ. Right? Right? Someone is saying something, maybe. Then we will see. We will see if any formula there. Okay, that is also okay. Is there anything possible? Is there anything possible? Something should be differ. Something should be differ. You cannot take as it is. You cannot take as it is. Please careful. Now listen. Now listen. One more combination I am giving. One more combination I am giving. Can you see this? One more combination I am giving. Is it okay? See this? Fine. Check everyone is covered exactly once or not verified. Yes. So let me give the path now. V3, V1, V4, V2, V3. If you see the numbers, E2, E5, E4, 6. Fine. Something differ. Something differ. But yeah, something differ. If anyone having small doubt, check the first one, second one. First one, second one, if you observe, what are the differences? I think in the first one, E6 not there, second one, E6 there. Right? Second one, third one, if you see, second one and third one, if you see, I think the second one having the E1, but third one don't have E1. If you see the first one and third one, first one don't have E5, but he is having E5. Can you give one more answer to me? Can you give one more Hamiltonian cycle where everything cannot be same? One more I want. One more I want. Can anyone find out? Remember, at least one edge should be different. Make it fast. Make it fast. At least one edge should be different. At least one edge. Those people who done already. Those people who done already. Can you say to me? One more. One more. So one is like this. First one is like this. Covering all, right? Like this. Right? Second one, if you observe, second one may be like this. Right? Third one is like this. V3, V2. Check, is it correct? If you see the third one, V3, V1, V3, V1, V1 to V4, V4 to V2, I think this one may be like this. This may be like this. Next one. What about the second one? V3, 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 V2. Okay. V1. Same. Yeah. Anything else? Anyone got? Anyone got? Anyone got one more? So I think Abhi saying something. Abhi saying something. Let me write and let me check. Abhi writing something. Let me write. V4, V2, V3, V3, V1, V2. See this one, E, right? Let me see the edges also. Let me see edges. V4 to V2, V4 to V2, so E4. Next, V2 to V3, V2 to V3, E6. V3 to V1, E2. Next one, V1 to V2, E1. Can you help me? These edges, E1, E2, E4, E6. E1, E1, E4, E6, E2, E1. Anyone like this? But if you see the diagram, see this one, V4 to V2, okay? If you see the diagram, afterwards you came here. You came afterwards like this. You came like this. Am I right? Array Gootley, starting ending should be same, na? This Gootley left total life he left out. Total life he left out. Array Gootley starting is equal to ending, na? Array Abhi, that is a mistake. So that is a mistake what you done. That is the reason I also scared. How it came. So I think it is wrong. So I think now people got to know answer is 3. There is no meaning of writing the same person again and again. Sir, I will start from here, I will start from here. So there is no meaning. It is not a directed graph. See, it is a cycle, yeah. Cycle, you start anyway. There is a cycle. Whether you start from first vertex or second vertex or third one, it is total is one cycle only. Total is one cycle only. So totally you got to know 3. Totally you got to know 3. How it is came 3, I will explain. Everyone listen. Everyone listen. Can you help me now? Interesting answer. Interesting answer. Interesting answer. Everyone have to observe. Everyone have to observe. From which place I have to start? Can I start from anywhere? Careful. And one more thing. How many edges you can take? How many edges you can take? When you say cycle, 4 vertices cycle. How many? I think 4 edges. See the answer. First edge. Everyone observe. First edge I am taking. I can take only 4 edges. Observe properly. I can take only 4 edges. First edge. Please listen. First edge. I am there at V1. Listen. I am there at V1. How many possibilities I have? It is a complete graph. It is a complete graph. I am trying for first edge. I am at V1. I am at V1. With whom I will go? I am at V1. I am at V1. One vertex you select. Starting point you select one person. I selected V1. Can you say from V1, will I go V2 or V3 or V4? I am at V1. I am at V1. How many possibilities I have? 3 possibilities or not? Any one, right? From the V1, you can go to V2. You have to fix one starting point. Because based on starting point, the answer is not coming. See this one. Based on starting point, the answer is not coming because this total, anywhere you can start. One cycle. Start from anywhere. That is the reason you start from anywhere. So I started from V1. From V1, where I will go? Because of it is a complete graph. I can go to V1 to V2 or V1 to V3 or V1 to V4. So I have V1 having 3 choices. So 3 possibilities. 3 possibilities. Let us assume that. Let us assume that. Out of those 3 possibilities, 1 possibility you selected. Now you are, listen, I think 2 vertices are already covered. Vertices cannot repeat again. Vertices cannot repeat again. Now can I help you know? I am at V4. Second edge purpose, how many choices I have? I am at V4 now. Second edge purpose, how many choices? You cannot take the same vertex again. So what is the answer? I think already 2 vertices are gone. I think remaining is 2 more. So what is the answer? I think 2 more possibility. Either you can take E4 or E4 or E3. You can take one. Okay, let us assume that I took this. Second edge purpose, 2 choices I tried. Now see the answer. Third edge. Can you help me now? Third edge, how many choices? Third edge, how many choices? I want answer from you. Third edge, how many choices you have? Please check one time. Third edge, how many? Right, third one, how many I can take? Only one. Third one is only one. 3 vertices are over. Remember. At the end of the first edge, see this one. At the end of the first edge, right? Vertex, right? V1, V4 completed. At the end of the second edge, right? V1, V4, V3 completed. V1, V4, V3 completed. Now you have only one person. Who is that? Now you have only one person. Who is that? V1, V4, V3, and V2. V2. So you have, I think, V2. You will go here. Now lastly, you have to take 4 edges because it is a cycle. You have to take 4 edges because you have a cycle. So what is the answer now? That is by default. Starting vertex. You have to go back to starting one choice. You have to go back to himself. V1, V4, V3, V2. From there again V1. So last 2 people are one choice. Right? Last part is 1. Now I think if you observe clearly, listen, this is the answer. Number of, see this one, everyone listen. Number of Hamiltonian cycles. Number of Hamiltonian cycles in K3 is equal to, right? 3 into 3 possibilities first, 2 possibilities next, 1 possibility next. Forget about last one because that is a by default should come back. 3 into 2 into 1, which is going to be 6. Listen, which is going to be 6. But the thing is, same thing will be counted twice. Divide by 2 unit, which is become 3. Same thing counted twice, double will come. If anyone having small doubt also, all 6 possibilities you write. All 6 possibilities you write, you will get to know. Some people are asking, sir, how can you say double will come? Very simple. I'm giving the answer. See this one? This formula is giving like this one. It is one path it is taking. It is a one Hamiltonian cycle. This is giving reverse also one more. Similar way here also. One is like this, one is like this. One is like this, one is like this. Reverse also happening. That is the reason double came. If you want, you can write and check. So first 3 possibilities, all 3 possibilities you write. Next 2 possibilities, all 2 possibilities also you write. So I will try this. If you want, only for listing purpose, I will try. Can you see this one? What he says? Listen, 1. First I am at 1. From 1, you have 3 possibilities. You can go to 2 also, 3 also, 4 also. I meant 2. After 2, you can go to 3 or 4. I will go to 3. Right? Afterwards, I will go to 4. Lastly, 1. Now see the one more. 1, 2, 1, 2. See this one. 1, 2. Right? I think 3, 4. 3, 4 can be written as 4, 3. Followed by 1. So I think remember last 2 people I swapped. In the similar way, first person also I can swap, right? So let's see this one. 1, I kept 2. I kept second place 2. I have 2 possibilities. Let me keep second place 3. 3. Remaining people are 2 and 4. 2, 4, 1. 1, 3. 2, 4 as 4, 2. All possibilities covering. So I think second place 3 also over. Second place keep 4. 1, 4, 2, 3, and 1. Next one. 1, 4, 3, 2, and 1. Now, if you observe clearly, any repetition, this is, listen, 1, 2, 3, 4, 1. Reverse order also same. 1, 2, 3, 4, 1. Starting with 1. Totally, these are the possibilities. Can you see any repetition? Check anywhere repetition. Now, one small question I want to ask you. One small question. In the first one, 1, 4, 4, 1, 1, 4, both are same. In the first one, 1, 4, all edges. If you want, you can give edge numbers also. I don't have any problem. You can give edge number, you can check properly. So can you help me? In the first one, you only say first one, 1, 2 edge there. Where is the 1, 2 edge in the remaining? In the remaining, where is the 1, 2 edge? Except the first one, anyone? No. Okay, fine. Next one. Can you help me now? 2, 3 edge there. Why 1 and 2 differ? Why 1 and 2 differ? Let's see, 1 and 2 differ or not? 1, 2, 1, 2. Is there any 1, 2 in the second one? There. 1, 2 there in the second one. Next one, 2, 3. Is there any 2, 3 in the second one? No. 2, 3 not there. So they are different. Now, can you come to the next one now? Can you come to the next one? 1, 2 there, 1, 2 there, 1, 2 there in the third one. 1, 2 there in the third one. No. No, third 1, 2 is not there. That is also okay. Next one. Can you help me now? Any repetition? Can you identify? Someone is saying first and reverse same. Let's check because of someone saying first and last one same. Let me check. Is 1, 2 there in the last one? Yes. Is 1, 2 there in the last one? Yes. Is 2, 3 there in the last one? Yes. Is 3, 4 there in the last one? Yes. Is 4, 1 there in the last one? As it is copy. As it is copy. Who bother about order? So take only one. Take only one. Next one. Next one. Can you check again? I think one more, I think two more we have to delete. Let's verify. Let's verify. Is 1, 4 there in the first one? Yes. Is 4, 2 there in the second one? In the first one? No. Next one. Let's the second one. Is 1, 4 there in the second one? No. Let's go to the third one. 1, 4 there in the 1, 4 there in the third one? Yes. 4, 2 there in the third one? Yes. Next one. 2, 3 there in the third one? Yes. I think this is the copy of this. Check. 1, 3 there here. Here also 1, 3 there. 3, 2 there here. Here also 3, 2 there. 2, 4 there here. Here also 2, 4 there. 4, 1 there here. Here also 4, 1. So copy. Next check. One more we have to delete. Which one? Let me know. Is 1, 3 there? Is 1, 3 there anyway? Yeah, let's check the upper one. This only check. Is 1, 3 there upper? Yes. 3, 4? No. Yeah, can you help me out of these 4? Who two are same? Someone is saying 2, 4. Check. Someone is saying 2, 4. Verify. 1, 2 there. 1, 2 there. 2, 4 there. 2, 4 there. 4, 3 there. 4, 3 there. So 2, 1 also there. So cancel 1. So that is the answer. That is the reason repetition came. So reverse also coming. So number of Hamiltonian cycle for K3 is, find out this, divide by 2, you will get it. Right? Because of your little bit okay. Now let me check once again. See this one. Number of Hamiltonian cycles present. Everyone observe. Number of Hamiltonian cycles present. Number of Hamiltonian cycles present. Observe properly. Observe properly. K, see this one. K25. K25 or K20. Some number. K20. Now see one by one. Can you say first possibility how many? Totally how to take 20 edges. Totally how to take 20 edges. What is the answer? Yeah, if at all directed, directions also important. True. In the directed graph, 1, 2 different, 2, 1 different. In the directed graph, 1, 2 possible doesn't mean that 2, 1 possible. You have to take it as different. Thank you so much for asking. If it is a directed graph, don't do by 2. Directed graph, don't do by 2. Because 1, 2 different, 2, 1 different. Now can you help you know? Hamiltonian cycles, how many for K20? Listen, 20 vertices are there. First edge purpose. Go to one of the vertex. How many possibilities? First edge purpose. How many possibilities? Go to one of the vertex. I think he can go with the 19 people, anyone. 19 possibilities. So now if you observe V1, V2, 2 people are completed. Now you are at one of the vertex. Out of those 2 people, one of the vertex you are. Second edge purpose, how many? Second edge purpose, how many? I want answer from you. Already 2 people are over. You are at a second person. You cannot repeat. Now I think remaining 18 people, you can go in. V1, V2, V3. Now 3 people are out. Now third edge purpose. Third edge purpose. If you want, you can check remaining 17 people anywhere. Continue like this. Continue like this one. Last edge purpose means 20 edge. Last edge purpose. I think 1 possibility. So totally number of Hamiltonian cycle. Number of Hamiltonian cycle in K20 is equal to number of Hamiltonian cycle in K20 is equal to. What is the answer? 19, 18, 17, and so on. 2 and 1 by 2. Because it is that undirected graph, 1, 2 same equal to 2, 1. which is going to be 19 factorial by, right? That is the answer for this. Now, similar way, last attempt, number of Hamiltonian cycle in Kn is equal to n minus 1 factorial by 2. Right? By 2. Is it fine? Next one. This is for a directed graph. Right, let's go to undirected. What is the answer? Number of Hamiltonian cycles in Kn is equal to by 2, not equal to 1, 2, 2, 1, same. Yeah. This is the undirected. Can we move to next? We really done very good work today. Today we done very good work. Are you fine? Can we move to next? Can we move to next? Gayatri, can we move next? Gayatri, can we move next? Gayatri gone. She is gone. I got my sixth sense saying Gayatri gone. That is the reason I asked, I am right. Someone is saying K3 you did 3 factorial. Na wait. K4, na, it's a K4, na bhaiya. Bhaiya brain completely gone. Bhaiya brain is completely gone. It's gone. Chalo. Can we go to next? Can we go to next? Say yaar, say bolo yaar, bol do yaar, bol do yaar. You wrote K3. Where I written K3? Someone is saying you wrote K3. Where I written? Where I written? It's K4, na? Array. Somehow I controlled. I controlled somehow. Where I said K3? Where I written K3? Array, Gootle. Oh, here I written. Here I written. You could have said to me. You could have said to me that time after total Ramayana is over. Rama and Sita, what is the relation? Total Ramayana is over. Rama and Sita, what is the relation? Ready, sir? Ramayana over, na? Rama and Sita, both brother and sister. Array, man, if BJ people will listen, they will kill you. They will kill you. After Ramayana is over, you are saying, ready, sir? Rama and Sita, are they siblings? If BJ people will listen, they will kill you. They will kill you, I am saying. Bhai Behan, exactly, man. Right. Yeah, maybe some people will send, right? In one of the class, I said something like this. One person sent, how can you misuse Bhagavad Gita? I said in one of the class, Bhagavad Gita. Don't write big stories like Bhagavad Gita. He said message, how can you write Bhagavad Gita? How can you misuse Bhagavad Gita? I said, one kick if I do with leg. One kick only. Right? Brain becomes, right, two parts. One part will go this side, one part will go this side. Then that shameless person said, yeah, I seen this kind of things will happen in South movies. I am shouting on you. You are saying that these kind of things will happen in South movies. If I give one kick right in the head, one part will go this side, one part will go that side. I said, I'm scolding you. I said, I'm scolding you. He said, I want that only. Can you do few more? I am missing you ready, sir. Can you do more? What can I do? Other than blocking, what can I do? It's actually a proverb used frequently in my state. Okay, fine. Can we move to next? Bhaiya, okay. Proverb your state, okay, bhaiya. Can we move next? This bhaiya never say, can we go next or not? Okay, move. Okay, fine. He's saying that, what nonsense it is. What the headache? Move then. Okay, I moved now. Now listen. Next topic, everyone careful. Next topic, everyone careful. The topic name is called matching. That topic name is called matching. Fine. The topic name is matching. It is not array hidden. It is not match fixing. Just matching one. It is not match fixing. Sayan thinking that Sayan is from Mumbai. Sayan is from Mumbai. Sayan is thinking that I am from Mumbai. Can we go for match fixing? Arey bhaiya, that is not match fixing. Just matching. Sayan thinking that I am from Mumbai. Fixing is normal to me. Normal, right? Mumbai people, fixing is normal. Fixing normal, already, sir. In my area, fixing normal. Right? It's not match fixing. I am writing also. Not match fixing. Cyan, remember. It's not match fixing. Cyan, remember. Remember cyan. You may be good in that. I am from Calcutta. Oh, fine. So okay, assume you are from Mumbai. Assume you are from Mumbai. Oh, I thought you are from. Yeah, fine. It's okay. Assume that what is there in that. Okay, sir, no problem. Fine. Right. I'm starting. See this one. Everyone listen. Matching. It is not a match fixing. Please careful. Now I'm saying one interesting story. Very easy. It's a very easy. Name may be difficult. Name may be difficult. Can you see this one? V1, V2, V3, V4. V1, V2, V3, V4. Careful. Everyone observe. Everyone observe. Interesting one. Interesting one. Right? Everyone have to observe. Everyone you have to observe. Matching what? Remember. First of all, so they will ask you what is the matching number of the graph. They will ask you what is the matching number of the graph. They will give one graph. They will ask you what is the matching number of the graph. See how the problem. They given this graph. Yeah, I think same diagram. Yeah, perfect. Now see this one. They will give one graph. Observe properly. They will give one graph. They will ask you, right, to the given graph, what is the matching number of the graph? If you can listen, right, few examples, you will get the full clarity. For the given graph, what is the matching number of the graph? So see the answer. Matching number of the graph, first of all, right, it should be a subgraph. It should be a subgraph where all vertices should be there. Can you help me? Is it subgraph where all vertices should be there? Matching, right? Matching. First of all, if you want to find out matching number of the graph, you have to first of all find out matching. Now see the answer. Some people are asking, sir, is it matching, sir? Ready, sir, is it matching? Remember. First of all, matching of a given graph is first of all subgraph, where all vertices should be there. Okay. So this is a matching, where all vertices should be there. So it is a matching. Now see this one. Everyone listen. First of all, it should be a subgraph where all vertices should be there. Okay. So one matching I already given. One more matching I am giving. Can you observe this? One more matching. All vertices should be there. Listen. All vertices should be there. Where first of all, it should be a subgraph. All vertices should be there where every vertex degree is maximum 1, at most 1, where every vertex degree is maximum 1. So it is also a match. First of all, it should be a subgraph. Okay. And one more, every vertex should be there. That is also okay. Every vertex degree is maximum 1. It cannot cross more than 1. It is also a matching. It is a matching number 1. It is a matching number 2. First of all, it should be a subgraph. Now see the one more matching. V1, V2, V3, V4. First of all, it should be a subgraph. Yes, all right. One more condition: all vertices should be there. That is also okay. And one more: every vertex degree should be maximum 1. Maximum 1. I think this also. It is also match. Every vertex degree is maximum 1. It is also matching. It is also matching. Some people are asking, sir, can you give one more example? I'm giving. Can you see this one? V1, V2, V3. First of all, it should be a subgraph where all vertices should be there. Okay. Every vertex degree is maximum 1. Every vertex degree is maximum 1. Can anyone guess? See, careful. Is it matching? M4. Is it matching? Make it fast. 4 diagrams I written. First 3 people are matching. Last one is a matching or not? Last one is a matching or not? Exactly. What is the answer? So remember, it is not a subgraph. Remember, matching of a given graph is first of all subgraph. In the original graph V1 to V4, no edge. In the subgraph from where it came. Your papa given or my papa given? Original graph, right? You see this one. Sorry for this one. Everyone listen. Original graph don't have the edge V2 to V3. Original graph don't have the edge from V2 to V3. How this graph contain V2 to V3? Original graph don't have from where he got. So remember, right? This is not a subgraph first of all. Matching is a first of all. It is not a matching. Because not subgraph. Very good. Thank you so much, whoever is identified this mistake. It is not a matching because it is not a subgraph. Matching of a given graph is first of all subgraph, where each vertex degree is maximum 1. So it is not a subgraph first of all. Can you see this one? V1, V2, V3, V4. Careful everyone. Yeah. Can you say is it subgraph? I want an answer from you. Is it subgraph? Yes. And one more. Every vertex degree is maximum 1. Someone is saying it is not present. This edge is present. V1 to V4 present. So I think it is a match. M5 is a match. Next one. V1, V2, V3, V4. right? So now see this one. Listen, I'm giving one small thing. Is it subgraph? M6. Is it subgraph? Is it subgraph of the given graph? Is it subgraph of the given graph? Yes, yes. But every vertex degree should be maximum one. From where he got 3, right? Maximum 1, but someone is having 3. It is not a match. It is a subgraph, but not match. Right? It is not a matching. So remember, so in the given problem, for the given graph, so many matchings possible, I written. So many matchings possible, maybe some more also there. For the given graph, these many matchings. So now say the definition. What is the definition of matching? If you want, you can write the definition here itself. Yeah, say the definition, I will write. Say the definition one time. Matching S of the given graph G, V, comma E, matching S of the given graph G, V, comma E, if and only if. First condition, 1, S should be subgraph. Subgraph of G. Matching S of the given graph G, V, comma E, if and only if 1, S should be a subgraph of G. Okay. Second, S should contain all vertices of G. That is the second point. See the third point. In S, each vertex degree is maximum 1. In S, each vertex degree is maximum 1. You write whatever way you want. Whatever I feel that time I am writing. In S, each vertex degree at most 1. In S, each vertex degree at most 1. Matching S of given graph G, V, comma E, if and only if S should be subgraph of G. Second, S should contain all vertices of G. Third, in S, each vertex degree is at most 1. Any doubts, let me know. Simply whatever we discuss, I just given the examples. I given the definition. Write in your own terminology. You want to write in single line, write. You want to write in single line, you write. But actual meaning is this. Subgraph, right? Listen, given graph, for the given graph, S is said to be a matching. First of all, S should be a subgraph. Second, all vertices should be there. Next one, each vertex degree in the S should be maximum 1, at most 1. So I think by satisfying that definition, so we got to know M1 is a matching, M2 is a matching, M3 is a matching, M4 no, M5 yes, M6 no. And one more beauty. Listen, one more beauty. In the M3, each person degree 1 or not? In the M4, each person degree 1 or not? In the M4, each person degree 1 or not? Say or. Sorry, in the M3, every person degree 1 or not? Every person degree. First of all, it is a matching. Every person degree 1. This is called perfect matching. Every person degree 1. That is called perfect match. Means one vertex also cannot be left out. There should be a linking. Like that. So some connection will be. Every person degree. So some people are asking, what is the meaning of perfect matching? What is the answer? Every vertex degree is exactly 1. Every vertex degree is exactly 1. Degree exactly 1. Perfect matching. Each vertex degree exactly 1. Each vertex degree exactly 1. This is the perfect matching story. Fine. I hope you are okay. Each vertex degree exactly 1, then perfect matching. First of all, it should be a matching. And in that matching, every vertex degree is exactly 1, perfect matching. Okay, fine. So totally, how many are matchings? Say one by one. How many are matchings? M1 is a matching. M1 is a matching. Yes. M2. Yes. M3. Yes. M4. No. M5. Yes. M6. M6 matching? No. Next one, matching, okay. Next one. What about perfect matching? Every person, first of all, it should be a matching, okay. Perfect matching. Every person degree 1? No. First of all, it should be a matching. Every person degree 1? No. First of all, it is a matching. Every person degree 1? Yes. First of all, is it a matching? No concept of perfect matching. Is it a matching? Every person degree 1? No. Check M5. Every person degree 1? No. Next one. M6, is it matching? No. Okay, this is also okay. I am very happy till now. I am very happy till now. Now can you see the one more story? One more small story. One more small story. Can you listen? One more small story. Can you listen? The people who are not matching, no need to discuss. The people who are not matching, these people, see, anyhow, they are not right, they are not correct. So no need to waste time. No need to waste time. Right? Okay, if you write also what you lose. Okay, fine. Until now, okay. You know what are the matching, you know what are the perfect matching, everything is fine. Can you see how many perfect matchings? Only one. Matchings are, I think, almost like 4. Now observe properly, observe properly. Observe properly. Everyone have to understand this. Everyone have to understand this. Maximal matching. What is the meaning? I will explain. Maximal matching. Can you go to the interesting answer? Interesting answer. Interesting answer. Can you go to everyone observe? Everyone observe. In the M2 matching, can I add one more edge without violating the property? Over. Arey Ashwini, over, man. Ashwini, it's over. Can you help me now? In the M1, I'm repeating once again. In the M2, can I add one more edge without violating the matching? Without violating the matching property, can I add one more edge in the M2? In the M2, can I add one more edge without violating the matching property? Can I do or not? Can I do? Can I do? Without violating the matching property, can I add one more? If you can do that, it is not a maximal matching. In the M1, without violating the matching property, can I add one more? Yes. Can I add one more edge? Yes. So it is also not maximal matching. In the M3, it is a matching, okay. Without violating the matching property, can I add one more? No. It is a maximal matching. M1 is not a maximal matching because still I can add one more edge. Few more edges I can write. M2 also not maximal matching because few more edges I can write. M3 is a maximal matching. Let me write one by one now. Maximal matching. M1 is a maximal matching? No, because still addition possible. M2 is a maximal matching? No, still addition possible. M3 is a maximal matching? Yes. Can you go to M4? M4 is not a matching at all. Can you see the interesting answer? Interesting answer. Is M5 is maximal matching? I want answer from you. Is M5 is maximal matching? M5 is maximal matching or not? Yes or no? It's a very tricky question. Very tricky question it is. M5 is maximal matching or not? Yes or no? Is it maximal matching, or can I add one more edge without violating the matching property? Without violating matching property, can I add one more edge? If you add one more, listen, if you add one more, can you see this one? If you add one more, someone is saying one more I will add. If you add like this, you will become degree 2. If you add like this, it will become degree 2. If you add like this, it will become degree 2. You may say that, sir, I will add like this. There is no edge in the given graph. There is no edge like this in the given graph. I think there is no way. If you add one more edge, it is no more matching. Further addition not possible. Further addition not possible. Remember, M5 is a maximal matching because further additions are not possible. Further additions are not possible. It is a maximal matching. It is not a matching at all. Now, again, I'm asking you, how many maximal matchings you got? So some people are asking, sir, what is the meaning of maximal matching? Can you help me now? What is the meaning of maximal matching? Maximal matching is a first of all matching where you cannot add one more edge without violating matching property. If I add one more here, right, definitely matching property will fail. Because if you add the V1 already 1, it will become 2, matching fail. If you add to V1 to V3, V1 fail. Next one, if you keep the V3 to V4, V4 fail. If you keep V2 to V3, first of all, in the original graph, V2 to V3 not there, from where he came. So I think remember, in all the graphs, right, M3 is a maximal matching. And one more thing is M5 also maximal matching. Remember. Can you say this maximal matching contain how many edges? This maximal matching contain how many edges I want? This maximal matching contain 2 edges. This maximal matching contain 1 edge. First of all, find out the maximal matchings. I think this maximal matching contain 2 edges. This maximal matching contain 1 edge. Remember, out of those 2 people, who is the bigger one? I think 2 edges are none. So remember, 2 edges. 2 edges is bigger. This is called matching number of the graph. This is called as matching number of the graph. Matching number of the graph. Matching number of the graph is going to be 2. They will give this graph. See, this much story there. They will give this graph. They will ask you, what is the matching number of the graph? First of all, find out all matchings. First of all, find out all possible matchings. In all of them, which are maximal matchings, find out. Next one, after finding maximal matching, in every maximal matching contain how many edges? Calculate. Whichever having more edges, right? How many edges are there? Calculate. 2 edges or more, right? So 2 edges. Matching number of the graph is 2. Is it okay? Bhaiya, is it okay? Someone is saying all perfect matchings are maximum, of course. Yeah, you got it. Till now you got it. Till now you got it. Bhaiya, till now you got it. Till now you got it. See, problem to problem you will grow. Don't try everything now only. Right? Just understand the definitions. Understand definitions. Right? Only perfect matchings has maximum number of it. Cyan. If I give one kick, now you are in West Bengal. One kick if I give, you will go to, right? You will go to Pakistan. One kick if I give from West Bengal, you will go to Pakistan. Not Mumbai also. Not Mumbai also. You will directly go to Pakistan. He's saying only perfect matchings has maximum number. Bhaiya, control few more minutes. Definitions are going on. Definitions are going on. Why you want to kill people? Right? Why you want to kill people? Sayan, you may get the clarity. Let's see further. Can we move to the next story? Can we move to the next? Just definitions done. Just I done definitions. Just definitions done. Can we go to the next example? Can we give next example? Can we go to next example? Perfect. Good people. Perfect. Good people here. So matching number of the graph is 2. See, because of some, you may say that, sir, why should I take maximum, sir? The name itself saying maximal, maximal. Why I tried for maximal? I want to take maximum at the end. Out of all maximal matching, which contain more edges? Which contain more edges? That is the matching number of the graph. That is the matching, whichever contain more edges, that is called, right, that number. How many edges are there? That is called matching number of the graph. Some people are asking, sir, two edge, right? Maximal matching contain two maximal matchings are there. See this one. Two maximal matchings are there. Out of them, this maximal matching contain more edges, right? Sir, what is this graph is called? What is this maximal matching? This maximal matching is called maximum. Maximum. In all maximal matchings, whichever is the maximum, so that person is going to be maximum matching. No one will ask you, but who cares at the end of the day? Whoever having more edges, that person is your answer. What is the requirement of unnecessarily increasing? In all the maximal matchings, whichever having more edges, that person is called as maximum matching. How many edges are there? That is called matching number. Right? This graph is going to be maximum matching. Is the maximum matching. In all maximal matchings, whoever having more edges, that person called as maximum matching. Maximum matching. How many edges are there? Two edges. Matching number of the graph. Right? You are okay? So now my question is going to be, I will give one graph. You have to say directly what is the matching number of the graph. Try one problem. What is the matching number of the graph I am asking? I will give one graph. You have to say what is the matching number of the graph. Try your level best. V1, V2, V3, V4. I already said to you, other than logic, all will be very easy. Logic also, if you study 2 or 3 times, that will also become easy. So this is the graph. If you plan properly, total graph theory you can study one day. One day you can study. First complete all. Total graph theory first complete all. Make nice notes. Revise 1 or 2 times. It's over. This is the graph. I want matching number of the graph. Whatever you are thinking, you matching number of the graph. Let's see how many people will give. Let's see how many people will give. Matching number of the graph. Almost, DS is almost over here. 1 or 2 classes are there. Try properly. Yeah, fine. I'm giving the answer. You tried yourself. There can be many subgraphs. Yeah, that is the reason I given enough time. That is the reason I given enough time. Can I go ahead? Can I give answer? You tried your level best. You tried your level best. Can I go? Can I give the answer? Now see the answer. See the answer. You want maximum one, right? Remember, you want maximum one, but it should be a subgraph. Try to add, see this one, without violating matching property. Try to add more edges. Without violating matching property, try to add more edges. Try to add more edges. I think now people can give this. See this one, interesting answer. Is it okay? Is it matching? I want to keep more edges. Is it matching? I want to keep more edges. Is it matching? Not only matching, is it maximal matching? You cannot add one more, check. Not only matching, is it maximal matching? Not only matching, is it maximal matching? You cannot add one more. So maximal matching. Now see the one more. V1, V2, V3, V4, V5, V6. I want to keep more edges. Already I kept 2. Can I do for more than 2? Because maximal matching, out of all of them, whoever contain more edges, that number is called matching number of the graph. Already my answer is 2. Can I increase more? Let's check. I think this also I can keep. Am I right? It is also matching. This is also matching, and one more thing is more edges also there. I cannot add one more. I cannot add one more. It is the first of all matching. I cannot add one more. So maximal matching. I think more edges are there. More edges are there. So let me write now. It is also maximal matching. But out of them, this person having 3 edges, this person having 2. So 3 is the matching number of the graph. 3 is the matching number of the graph. Is it okay? Bhaiya, is it okay? Match 3 is the matching number of the graph. Yeah, now come to one more interesting answer. Listen, come to one more interesting answer. Come to one more interesting answer. Everyone observe. Everyone observe. Everyone observe. Suppose I added one more vertex. V6 there. V7 is you. Everyone listen. V7. Can you help me? To this one, what is the matching number of the graph? To the modified graph, what is the matching number of the graph? Let me try once. Let me try once. 3 here, 3 here, and it is a one more. It is a one more. See this one. Interesting answer. One more. See the interesting answer. Am I right? One answer. One more answer. One more answer. Listen, one more answer is like this. One more answer is like this. Oh, do you believe or not? Listen, do you believe or not? Do you believe or not? For every graph, perfect matching is not possible. You only say odd number of people, how perfect matching is possible. One edge, 2 people will go out. One edge, 2 people will go out. One edge, 2 people will go out. 7 people are there. How it is possible? Can you help me now? For every problem, can you give perfect matching? For every graph, can you give perfect matching? No. If the graph contain number of vertices are odd, how perfect matching possible? Because for matching, one edge will cover 2 people. Because the degree 1 only possible. Degree 1 only possible, degree 2 not possible. So one edge 2 people out. One edge 2 people out. See, one edge 2 people out. One edge 2 people out. One more edge 2 people. 6 people, only one person with whom I will add. If I add with another person, definitely it is not a matching. So odd number of people, perfect matching is not possible. So, right? I think Sayan asked me I think a few minutes back. Matching number of the graph, if you want, go for a perfect matching. Are Sayan bhaiya, for every problem, perfect matching is not possible. For every problem, perfect matching is not possible. Am I right or not? For every problem, perfect matching is not possible. Am I right or not? If it is possible, if at all possible, I think answer is perfect matching only. Sayan, if at all possible, answer is perfect matching only. Sometimes not possible. Yeah, sometimes. It depending upon graph also. Sayan, it depending upon graph also. It depending upon graph. If at all graph don't have edges, from where I will bring? Graph don't have edges, from where I will bring? You only say. You only say graph don't have edges, from where I will bring? So it depending upon so many parameters, right? Sometimes perfect. I want to say that for every graph, perfect matching need not be possible. May be possible, may not be possible. Right? Fine. Okay. If possible, if at all perfect matching is possible, I think matching number of the graph, that only, because perfect matching means everyone is covered. If at all perfect matching is possible, how many edges are there in that? That is the matching number of the graph. But sometimes perfect matching is not possible. It doesn't mean that matching number not exist. It is there, some number. So for the given graph, this is also perfect. This is also right. See this one. This is also maximal matching. This is also maximal matching. I want to keep more edges. I already kept 3. One more edge I want to keep, but not possible. So this is also 3. This is also 3. Maximum also 3. More than 3 not possible. For the modified one, yeah. Anyhow, that is not our problem. Fine. Is it okay? Is it okay? Yeah. So now go and happily sleep. Now go and sleep happily. Some people are dying also. Some people dying also. Now please go happily. See, it is the best thing in your life. It is the best thing in your life. 3 hours continuously you are listening. 3 hours continuously you are listening. Tomorrow we'll see anyhow, right? 3 hours continuously you are listening. It is the best thing in your life. I still remember, right? I still remember. One of the class I taught 5 hours continuously. One of the class, right? I taught 5 hours continuously. Someone is saying no notes for this. What notes you want, Bhaiya? He's saying that no notes for this. What notes you want? See, Bhaiya got habitual. Bhaiya got habitual. See, I already given notes. See, I already given notes, matching definition given. Perfect matching definition. I have to say, take note 1, take note 2. This Bhaiya got habitual. Note 1, note 2, note 3. Someone is saying next day all holidays. Oh, that is the reason. Okay, fine. Good boy. Thank you so much for remaining. No notes for this. No notes for this. While taking subscription in the EPT, right? I said to you, notes I will write. Note 1, note 2, note 3 I will write. I said to you, Bhaiya, am I promised you? Hidden saying that you take 1 day 6 hours to us to break. I think every day we are taking that only, right? Morning 2 hours, right? We done already. Morning 2 hours, right? After evening 2 hours, and right night also 2 hours. We done 6 hours per day. We done continuously 6 hours. I try, right? 1 year I taught continuously 12 hours. 1 year I taught continuously 12 hours. 6, right? Almost like see. I done continuously 12 hours I taken, 6 hours one batch, 6 hours one batch. Sometimes I used to try the batch without break. Sometimes I used to try the batch without break. So I done great work. Abhi saying you are giving more than what you told me. Thank you, Abhi. Thank you so much. It was a nice compliment. So those days, right? In one of the year, right? 12 hours I taught, and I take the challenge. Can I teach 6 hours without break? Can I, right? Can I take the class without break 6 hours? I tried. So afterwards, one day I went to hospital. Afterwards, some problem is came. I went to hospital. Doctor said that you have kidney stones. Doctor said that you have kidney stones. I asked why kidney stones. He said that Reddy sir, you took 12 hours. Na? I said to doctor also so proudly, doctor, I used to take 12 hours class. 6 hours one class, 6 hours one more class. Without break I done. I said so proudly. Doctor said that is the reason you have kidney stones also. You have approximately, right, 8 kidney stones. 8 kidney stones you have. Yeah, nice achievement. You continue like this, right? 12 hours teaching without water. Without water you try. Right? Without water, 6 hours you try, na? Without water, 6 hours you try. Without water, 12 hours you try. Not only kidney stones, even bones also not available. You will die. Right? Very soon you will die. Right? Very soon you will die. I said, how can you talk like this? He said, just shut up. Chup karo, buffoon. He said like this. So proudly you are saying, right, 6 hours I taught without water. Is it achievement? Should I give Bharat Ratna to you? Should I give Padma Bhushan? Not only taking water, without water you taught 12, right, 6 hours. You are saying so proudly. Sir, you need to wear spectacles. I think Abhi, spectacle doctor also soon I will meet. I will meet soon spectacle doctor also. I will say so proudly. Every day 10 hours I am teaching. I am a teacher. I am so proud teacher. My students are praising me a lot. He will say, if you do that, maybe eyes will be removed. 13 days, 13 subjects finished it off. Prevention is better than cure. Okay. I asked my madam, can you bring some stylish spectacles? I asked my madam, can you bring some stylish spectacles? Because in the class I want stylish spectacles. She said to me, right, food itself is waste. You want spectacles also? To you, food itself is waste. You want spectacles also? What should I say? Sir, wear black one once. Madam is madam. Madam, whatever say, we have to agree. I think she will give order. Maybe jokingly she said. Jokingly she said. Maybe mostly she will give. Let's see. Yeah, with spectacle, black spectacles, maja aega. Can't go against Home Minister. True. True. If you go against Home Minister, over, game over. Chalo then. Sure. Someone is saying that, sir, can you keep YouTube thumbnail before 1 month of GATE? Array man, see, this 8, right? I think it will take 30 days, 30 lectures, approximately 3 hours like that. 30 lecture after 90 hours like that. Array, one buffoon taught, right? One subject 300 hours. Yeah, that buffoon is crying. On social media, that buffoon is crying. Array, not only teaching 300 hours, you are crying. Instead of rectifying, that buffoon is crying. Array, 300 hours, how can you teach? Yeah? Everything copied from book. Everything is almost copied from book, I think. To show their greatness, killing the people. Saying so proudly, right? Saying so proudly. I done proof also, give also, or a buffoon. Anyhow. Copy, paste and put all sides. True. But 250 means what here? When people will complete syllabus? Chalo. It's none of our business. Can we go further? Take care everyone. Good night everyone. Chalo.